All right, people. I believe everybody is doing great, nice, and absolutely fine. So, welcome to Unacademy NEET English. I hope all of you are doing great, having the good time. So, guys, light up the chats with the fire emojis if I am perfectly audible and visible to each and every single student. Okay. And most importantly, my dear NEET aspirants, I would want you guys to smash the like. I would want you guys to smash the like button, okay? Okay. And mark the attendance because liking the session means marking the attendance. That is very much mandatory. And let the people join, and we are starting the session accordingly. Let everybody come, let everybody join. Okay. Make sure all of you smash the like button. Yo, yo, yo. That's great. That's great. So we'll be starting this chapter, that is electrostatics. And when we talk about the chapter electrostatics, we say 4 to 5 questions are asked from this particular chapter when it comes to the NEET examination. Okay. And we will be discussing each and every single topic. Okay. Along with all the problem patterns in this particular chapter. Okay. That will be our goal. That is what we are supposed to finish by today itself. Okay. This is what we have to do. Yes. So, my dear NEET aspirants, let's first talk about, we say charge. Let's first talk about charge. Okay. Let's first talk about charge. Let's understand what this charge is all about. Electric charge. Okay. Electric charge. Let's start with electric charge. My dear NEET aspirants, this is the first topic that we need to study in we say electrostatics chapter. And most importantly, guys, the duration of the session is going to be 6 to 7 hours. We'll be finishing all the topics in 6 to 7 hours along with the problem patterns. Okay. Yes. Now, guys, take a look. Electric charge. What does this electric charge actually mean? Let's suppose I'll take a comb. This is the example that I keep taking every single time whenever I have to explain the charge. Let's suppose I have a comb over here. This is a comb. Okay. And I'm rubbing this comb with my hair. I start rubbing this comb with my hair. And there are small piece of papers placed over here. These are the small piece of papers placed over here. Now, if you take this comb near to the piece of papers, what's going to happen? We say these piece of papers will be attracted towards the comb. So these piece of papers will stick to the comb. These piece of papers will stick to the comb. Attraction will take place. My dear friends, if I say, don't rub the comb with your hair, just directly take this comb and take it near to the piece of papers. Will it attract? No, sir. Without rubbing the comb with your hair, it is not possible. It is not possible to attract the piece of papers. Yes, last year, the duration was long. Let me just tell you, whatever we have studied in the last year's session, we'll be completing all of those questions. And I have put many more also. Okay. Okay. That is the beauty of this particular session. Duration is going to be less. Content is going to be more. Trust me. Okay. Now, my dear NEET aspirants, so in this particular case, we say if you do not rub the comb with your hair, it is not going to attract the piece of papers. So when you rub the comb with your hair, only then it is attracting the piece of papers. So means. While rubbing the comb with your hair, something is occupied onto this comb. And that something is what we call charge. So means what I'm trying to say is that when you rub the comb with your hair, So charge is occupied onto this comb. Because of that charge, it is attracting the piece of papers. Yes, sir. So is it because of charge? Yes. So when you do not rub this comb with your hair, nothing is occupied onto this comb, so it is not attracting the piece of papers. So can I define this charge over here? Can I define this charge over here something like this? We say charge. Charge is something. Charge is something, or we say it's a property of a matter. Charge is something due to which a body shows electrical and magnetic effects. Magnetic effects. So this charge is something due to which a body shows electrical and magnetic effects. Magnetic effect means it is this attraction is taking place over here. Electrical effects we'll see later on. Or we'll say charge is something due to which a body attracts another body. You can also say it something like this. Charge is something due to which a body repels another body. That we'll see after some time. Okay. Now, my dear NEET aspirants, and I would suggest you guys to take the notes, okay? So, charge is something due to which a body shows electrical and magnetic effects. Charge is something due to which this body is attracting this particular body over here. Okay? Yes. Now, my dear friends, make sure you smash the like button because that is mandatory. When it comes to the types of charge, okay? When it comes to the types of this charge, we simply say you have got positive charge and you have got negative charge. There are two types of charge, positive and negative. So my dear NEET aspirants, if somebody asks you, what is the symbol of charge? What is the symbol of charge? We say symbol of charge is Q. Like symbol of mass is M. We say mass of this body M is equal to 2 kgs. Mass of that body M is equal to 4 kgs. Similarly, we say charge on this body is 2 coulomb, 3 coulomb, 4 coulomb. Okay. And when I say SI unit of charge is coulomb. Okay. Like we say, mass of a body M is equal to 2 kgs. What is M? M is the symbol. What is kg? Kg is the unit, SI unit. Similarly, we say charge on a body is 2 coulomb. So we say plus 2 coulomb. 2 coulomb positive charge is present on the rod. Like this is the rod. So 2 coulomb positive charge is present on this rod. This is how we represent it. So Q means symbol and coulomb means SI unit. Coulomb means SI unit. Okay. Yes. And one more important thing. If you have a positive charge over here, let's suppose there is a rod over here. There is a rod. Okay, on this rod you have got positive charge. And if you have another rod, on this rod also you have positive charge. We say positively charged rod will repel the positively charged rod, means positive repel. And if you have negative charge and negative charge, we say negative also repels. They also repel. If you place the two negatively charged rods close to each other, they will also repel. Because like charges repel and unlike charges attract. And if you have a positive charge and if you have a negative charge, we say in that case, attraction is going to take place. They will attract each other. So like charges repel, unlike charges attract. Yes. Now, my dear NEET aspirants, take a look over here. Neutral body. Sir, what does a neutral body actually mean? Listen carefully. Neutral body means if you have a rod, let's suppose over here, the amount of positive charge present on the rod, if it is equal to the amount of negative charge present on the rod, we say in that case, net charge on the rod is 0. And it is considered as neutral body. If I say this rod has plus 2 coulomb charge, this rod has minus 2 coulomb charge, we say it's a neutral body. and we say net charge on the body is 0. Now guys, let's suppose you have a rod over here, and on this rod you have got only positive charge. So we say this rod is positively charged, and in this particular case, when I say net charge, it is simply positive. Net charge is positive. And my dear NEET aspirants, if you have a negatively charged rod, over here, if there is a charge, if there is a rod, it has got negative charge, only negative charge, we say in this particular case, body is said to be negatively charged. Or, we define it like this also. If we say positive charge, if positive charge is greater than negative charge, if positive charge on a body is greater than negative charge, then it is considered as positively charged. If negative charge on a body is greater than positive charge, it is considered as negatively charged. Please tell me in the chats with the fire emojis if this is crystal and clear to each and every single student. Everyone means everyone. And make sure all of you are taking the notes along with me. Tell me guys quick if it is clear and crystal. Okay. Yo, that's great, boys and girls. Now let's move on to the properties of charge. The first property is charge is conserved. What does conservation of charge mean? Listen carefully. Let's suppose you have a box over here. Okay, I'm taking a box, and inside this box I have got three balls. This one, and this one. Okay. Inside the box, I have got three, I would say, spheres. This 2 Coulomb sphere, 3 Coulomb sphere, and 4 Coulomb sphere. Okay. Yes. Now, my dear friends, what I'm doing is that I'm taking this box to some other place. I'm shaking this box. I'm taking it up. I'm throwing it down. And finally, I would say, after shaking, I'm placing the same box over here. And when I checked inside this box, this first sphere, this first ball, previously I would say 2 Coulomb charge was inside. Now it has got 3 Coulomb charge. In the second ball, 3 Coulomb charge was inside the second ball previously. Right now it is 1 Coulomb. In the third ball, 4 Coulomb. Here it is 5 Coulomb. Now, can I say these balls, these spheres have transferred the charge between them? Obviously, sir. Can I say when these have transferred the charge between them? But one thing you see over here, what is the net charge initially? Net charge inside this box, 4 plus 3 is 7 plus 2 is 9 Coulomb. Now, what is the net charge finally? You see 5 plus 1 is 6, 6 plus 3 is 9. Sir, 9 Coulomb. You see, net charge of the box, net charge of the system is conserved. Whatever is the net charge initially, same as the net charge finally. No doubt, the bodies inside the box, inside the system, they have shared the charge between each other. But when it comes to the net charge, it remains conserved. That's what we say conservation of charge. Charge of the system remains conserved. Charge can neither be created nor be destroyed. Okay, no, neither be created nor be destroyed, but can be transferred from one body to another. These bodies are transferring the charge between them. But net charge remains the same. Like over here, my dear friends, you have got a box inside this. So this is 5 Coulomb and this is minus 2 Coulomb. Now inside this box, we say 2 Coulomb charge is transferred here. So could you please tell me if 2 Coulomb charge is transferred over here, what is the net charge? That is plus 3 Coulomb. So finally, guys, 5 Coulomb charge was inside this ball. Minus 2 Coulomb charge is inside this ball. So when you are transferring 2 Coulomb charge inside this, now plus 2 minus 2. So what will be the net charge? Finally 0. So charge will be 0. Now you see how much is remaining. Remaining is 3 Coulomb. So 3 Coulomb, 3 Coulomb. Net charge of the system remains constant. No doubt the bodies between, the bodies will share the charge between them, but net charge will remain constant. Second is quantization of charge. Quantization of charge. Let me make you understand quantization of charge. Take a look. Let's suppose, my dear friends, you have a shop 1 over here and you have a shop 2 over here. Shop 2. Let me give you this example. This shop 1 is basically selling the cricket balls. Cricket balls. Cricket balls. Okay. And imagine this shop 2 is selling the charge. This shop 2 is selling the charge. Shop 1 is selling the cricket balls. Shop 2 is selling the charge. Now, my dear NEET aspirants, listen to me very carefully. Listen to me very carefully. When it comes to the shop 1, this is a ball over here. It is selling the balls. I went to the shopkeeper. I asked him, could you please give me the smallest ball present in your shop? He said, take this ball. I said, no, smaller than this one. He said, take this ball. I said, no, smaller than this one. He said, take this ball. I said, no, smaller than this one. He said, take this ball. I said, smaller than this one. He said, smaller than this one is not possible. This is the smallest ball possible. Smallest ball possible or available. This is the smallest ball possible or available. Similarly, I went to the shopkeeper, shop 2. I asked him, give me the smallest charge that is available in your shop. He said, take this one. I said, no, smaller than this one. He said, take this one. Smaller than this one, take this one. Smaller than this one, take this one. I said, give me smaller charge than this. He said, it is not possible to get smaller charge than this. This is the smallest charge present in the entire universe. So I would say this is the smallest charge possible. This is the smallest charge possible. Now, if I say, sir, if this is the smallest ball, what is the size of the smallest ball? The size of this ball is, I would say its radius is 1 millimeter. This is the smallest ball. Sir, what is the value of this smallest charge? This is charge on 1 electron. So means whatever is the charge on 1 electron, that is 1.6 into 10 raised power minus 19 Coulomb. This is considered to be the smallest charge possible, charge on 1 electron. Similarly, sir, this is 1 millimeter is the radius of the smallest ball. Similarly, this is the charge. Sir, so means you are saying that this charge, the smallest value of charge is 1 electron. 1.6 in 10 raised power minus 19 Coulomb. Yes, whatever is the charge on 1 electron. So my dear friends, can I say over here, listen to me very carefully. We say charges possible. And I will write over here, charges not possible. Not possible. Charge is possible and charge is not possible. If I ask you, sir, what is the charge possible? Sir, 1 electron is possible. Sir, can you get E divided by 2, half of the electron? No. Why? Because this is the smallest one. If E by 2 was possible, then we would have considered that only the smallest one. This is the smallest charge possible. Sir, can you get me 2 electrons? Yes, this is possible. Sir, can you get me 2.5 electrons? 2 electrons are possible, but 2.5 electrons are not possible because half of the electron you cannot get. Sir, can you get me 3 electrons? Yes. Can you get me 3.75 electrons? No, not possible. Similarly, sir, can you get me n electrons? Yes, n can be 1, 2, 3, okay, and so on. Sir, can you get me these? These are not possible, these are possible. So what is the charge possible? Charge possible is Q is equal to n times of E. And more specifically, I'll write plus minus n times of E, where this n is an integer. N can be 1, it can be 2, it can be 3. Okay, it cannot be in points like 0.5, 0.75, 3.75. It cannot be like that. So we said this is the charge possible. This is the charge available. Okay. Okay. Yes. Now, my dear friends, this is what we call charge is quantized. Charge is quantized means charge is available in fixed amounts. Fixed amounts. Sir, charge is available in fixed amounts. What does that mean? Charge is not available in any amount, like E by 2 is not possible. 2.5 electrons you cannot get, but charge is available in this one. Like you go to a shopkeeper, guys. If you go to a shopkeeper, he is selling pens. If you ask this shopkeeper, give me one pen, he can give you one pen. If you ask him, give me two pens, he can give you one and one, 2 pens. If you ask him, give me 3 pens, one, so means 3 pens. If you ask him, give me half of the pen, is it possible? No. Half of the pen is not possible. That is useless. But if you go to a shop which is selling rice, give me half kg of rice, 0.5 kg, possible. Give me 250 grams of rice, possible. Give me 1.75 kg of rice, possible. So rice is available in random amounts. But charges, but pens are not available in random amounts. Pens are quantized. Pens are quantized. Okay. Similarly, charge which are possible, it is 1 electron, 2 electron, and so on. These are not possible. That's what we call charge is quantized. Charge is available in fixed amounts. Guys, give me the signal in the chats. Is this clear? Is this clear? Is this clear? Tell me, guys, quickly. And smash the like button. Mark the attendance. That's mandatory. Now, guys, let's suppose you have a question something like this. Check if the charge is possible. You have to check whether these charges are possible or not. Listen carefully. See, guys. We say, what is the charge which is possible? Q is equal to n times of E. This n must be equal to 1, 2, 3, 4, and so on. It should not be in the points, okay? Like in decimal points. See, guys. So we can say over here, n is equal to Q by E. This is the way by how you can figure out whether the charge is possible or not. What is the value of charge in the first case? Let's check if this charge is possible or not. Q means it is given as 1.6 into 10 raised power minus 18 coulomb upon E. E means charge on 1 electron. That is 1.6 into 10 raised power minus 19 coulombs. Okay. Yes. Now, my dear NEET aspirants, 1.6 you can cancel out. Take it in the numerator. So 10 raised power minus 18 and this will be 10 raised power plus 19. Because if you take it in the numerator, it will become positive. So 19 minus 18, that is 1. So this will become 10 raised power 1. That means 10. So it will come out to be 10. So yes, it is possible. Yes, it is possible. Let's check the second one. Let's check. This is the first one. Let's check the second one. Second one says n is equal to Q divided by E. So what is the value of Q over here? 1.6 into 10 raised power minus 19 divided by 1.6 into 10 raised power minus 19. This and this will cancel. N will come out to be 1. Yes, possible. Let's talk about the third one. So this third one, we say n is equal to Q divided by E. So what is the value of n in this Q over here? That is 1.6 into 10 raised power minus 19 divided by, this is, sorry, it is given as 10 raised power minus 20. Okay. So this is 1.6 into 10 raised power minus 19. This and this will cancel. So this will be 10 raised power minus 20, 10 raised power minus 19. So it will be 10 raised power minus 1. So 10 raised power minus 1 will be 1 divided by 10 and that is 0.1. Is it possible? No, not possible. Not possible. Not possible. Okay, like you have this question. Can a charge of 8 into 10 raised power minus 18 Coulomb be given to a body? See guys, you have to say N is equal to Q divided by E. What is the value of Q? That is 8 into 10 raised power minus 18 divided by E is 1.6 into 10 raised power minus 90. Now 8 divided by 1.6, it is 5 into 10 raised power minus 18, 10 raised power minus 19. So it will be 10 raised power plus 1. Why? Because if you take this in the numerator, it will become 10 raised power plus 19. Plus 19 minus 18 is plus 1. So this will come out to be 50. So answer is yes. Answer is yes. Okay. Next question. How many electrons are there in 1 Coulomb of charge? Listen to me very carefully. Guys. If you say charge Q is equal to 1 electron. If you say charge Q is equal to 2 electrons. If you say charge Q is equal to 3 electrons. What does this mean? Sir, this means in this particular case, value of N is 1. In this case, value of N is 2. In this case, value of N is 3. Okay. Why? Because E is the charge on an electron, means 3 electrons, means value of N is 3. So what does this N actually mean? N means number of electrons. Number of electrons. N means when we say Q is equal to N times of E, what is this N? N is the number of electrons. So you have to say how many number of electrons are there in 1 Coulomb of charge. So means you have to find the value of N over here. Okay. So how do we find N? N is equal to Q divided by E. So it is saying you have to find out how many electrons are there in 1 Coulomb. So means charge is given as 1 Coulomb upon 1.6 into 10 raised power minus 90. Okay. Now guys, it is like this. Let me show you. It is like this. It is like this. If I say how many electrons are there in, 1.6 into 10 raised power minus 19 Coulomb charge. If this is the charge given, I'm asking you how many electrons are there in this much amount of charge. You say simply, sir, N is equal to Q divided by E. Value of Q is 1.6 into 10 raised power minus 19. Okay. Divided by, this is 1.6 into 10 raised power minus 19. This and this will cancel. So it will come out to be 1. Similarly, you have to figure out over here. So 1 divided by 1.6, it means 0.625. Into 10 raised power minus 19. If you take it in the numerator, it will become 10 raised power plus 19. Now guys, see, this is 625. 0.625. You can write it like this. 625. See, after the decimal point, how many digits? 1, 2, and 3. So you can write it like this. 1 and 3 zeros. Sir, means if you have 0.5, how can we write this? After the decimal point, you have 1 digit. So you can write 5 divided by 1 and 1 0. Yes or no? Now guys, so 625 divided by 1000 into, we say 10 raised power 19. So 1000 means 10 raised power 3. So 10 raised power 3, and here 3 zeros will be cancelled. So it will remain 16. So it will come out to be 625 into 10 raised power 16. I hope you know this much of maths. Please tell me in the chats if this is crystal and clear. Everybody out there. Tell me guys if this is crystal and clear. Tell me about this one. Is this charge possible? Q is equal to 0.3e. 0.3e. Is this charge possible? Sir, 0.3e, is this charge possible? Yes or no? Yes or no? Guys, compare this. Q is equal to N times of E. See, this is E, this is Q, and in this particular case, N is coming out to be 0.3. Is this possible? No, sir. But if you take Q is equal to 0.3C, there is a difference if you take this as C. This is C and this is E. This is C and this is E. In this particular case, you can say Q is equal to, guys. In this particular case, we say N, you can use here. You can use over here N is equal to Q divided by E. What is the value of Q? that is 0.3. What is the value of E? 1.6 into 10 raised power minus 90. Okay. Okay. So 0.3 divided by 1.6, it is coming out to be, I guess, 0.18 into 10 raised power, we say 90. Oh, yes or no? So this will come out to be 18 into 10 raised power 70. I hope this is crystal and clear. So means, is this possible? Yes, it is possible. So value of n is coming out to be 18 into 10 raised power 17. Yes, it is possible. But tell me in the chats with the fire emojis if this is crystal and clear. Everybody out there. Everybody out there, is this crystal and clear? Tell me, boys and girls. That's great. That's great. Now let's talk about charging a body. Let's talk about charging a body. What does charging a body mean? Like the first example that I gave, when you rub the comb with your hair, something is occupied onto this comb. That something was charged. That something was charged. So basically, that was the first method by which you can charge a body. That is rubbing, charging by rubbing. Or you can say that is what we call charging by friction. Charging by rubbing means charging by friction. So while rub the comb with your hair, it gets charged. Now another example is you have, let's suppose, a glass rod. Take a glass rod, rub it with the silk cloth. Rub it with the silk cloth. Okay. This is also here in this particular case. When you rub the glass rod with the silk cloth, listen to me very carefully. This is another example. When you rub the glass rod with the silk cloth, we say negative charge is transferred from the glass rod to the silk cloth. If negative charge is transferred from the glass rod to the silk cloth, so on the glass rod, negative charge is transferred. What remains over there? Positive, 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 positive. So this will become positively charged. And this silk cloth in this particular case will become negatively charged. Why? Because in this case, now more negative charge and less positive charge. So when you rub a glass rod with the silk cloth, we say negative charge from the glass rod transfers to the silk cloth. Initially, this was neutral. But after rubbing, negative charge is transferred here. This becomes positively charged. This becomes negatively charged. Okay. So my dear NEET aspirants, we say mass of this is decreased. Why? Because negative charge has transferred. Charge has mass. And mass of this is increased. Why? Because charge has increased on this silk cloth. So this is the first way by which you can charge a body. That's what we call charging by friction. So I'll just write over here. It is to charge a body by rubbing. It is to charge a body by rubbing. It is to charge a body by rubbing. Second one is charging by conduction. See, first one is you have to rub a body with another body, it gets charged. Second one is you don't have to rub the body, but it is to charge a body by touching. So when you touch two bodies, we say in that particular case, the body gets charged. That's what we call charging by conduction. In case of conduction, we only touch two bodies. Here, this glass rod, this silk cloth, both are insulators. That's why rubbing was necessary. But in this particular case, we say these are conductors. Okay, so we say valid for conductors. So my dear NEET aspirants, listen to me very carefully. Let's suppose this is a positively charged sphere over here. And this is a neutral sphere over here. Net charge on this sphere is 0. Net charge on this sphere is 0. Now let's suppose you are touching this sphere, or you are connecting these two by means of a wire. That is also what we call touching. Okay, touch. When you touch this positively charged sphere with uncharged sphere, this is uncharged. Uncharged. And this is positively charged. Positively charged. When you touch this positively charged sphere with uncharged sphere, we say it transfers some of the positive charge onto this sphere. It transfers some of the positive charge onto this sphere. Now, first one was already positively charged. Now, this second one will also become positively charged. Second one will also become positively. So, in case of conduction, you touch two bodies. So, charge gets transferred from that body which has charge to the uncharged body. Okay. Like my dear NEET aspirants, this is an example over here. This is an example over here. Let's suppose this is a sphere. On this sphere, we have 4 Coulomb charge. And on this sphere, we have 2 Coulomb charge. Let me just tell you one thing over here. Let me just tell you one thing over here. Let's suppose you are touching these two bodies. Okay. When you touch these two bodies, they share the charge between them. And what is the net charge? Could you please tell me what is the net charge? Net charge is 4 plus 2 is 6 Coulomb. Sir, you have studied previously. We have studied previously. Net charge of the system remains conserved. So can I not say finally also net charge is going to be, we say 6 Coulomb. Finally also net charge is going to be 6 Coulomb. Now. We say, sir. When you touch these two bodies, they share the charge between them. Net charge is 6 initially, net charge is finally 6. Now, 3 Coulomb will be occupied onto this. 3 Coulomb will be occupied onto this. So the point over here is, in this particular case, we say, if the two spheres are identical, if the two spheres are identical means same in shape, same in size. If the two spheres are identical, then charge shared between them is same. Then charge shared between them is same. If the two spheres are identical, then charge shared between them is same. Okay. Or I would say then charge on each sphere is same after the conduction. Okay. Identical means same in shape, same in size. Okay. Yes. Let's suppose if I give you the question over here, something like this. Take a look, guys. Okay. This is a sphere over here. This is another sphere over here. And on this sphere, you have got plus 8 Coulomb charge. On this sphere, you have got minus 2 Coulomb charge. We say after the conduction, what is going to be the charge on first sphere? What is going to be the charge on second sphere? Both the spheres are identical. Guys, what is the net charge initially? Net charge is 8 minus 2. 8 minus 2. That is going to be 6 Coulomb. So what must be the final charge? Finally, also it must be 6 Coulomb plus 6 Coulomb. Now, don't you think that on this one we say plus 3 Coulomb will be occupied? On this one we say plus 3 Coulomb will be occupied. Absolutely, sir. Absolutely, sir. Sir, what if the two spheres are not identical? If the two spheres are not identical? Sir, what if the two spheres are not identical? What will happen in that particular case? Listen, guys. If you have got a sphere over here, charge on this is Q1. If you have got another sphere over here, charge on this sphere is Q2. And radius of this sphere is R1, radius of this sphere is R2. Okay. Sir, why not 5 and 1? Because I told you, if the two spheres are identical, then charge after the conduction on both will be same. 3 and 3, equally distributed. Equally distributed. Now, if the two spheres are not identical, okay, then, guys, we say these two are touched, connected by means of a wire. Now, charge on this sphere is, let's suppose, Q1 dash. Charge on this sphere is, let's suppose, Q2 dash. You have to tell me the value of Q1 dash and Q2 dash. Okay. Now, guys, Q1 dash will be, no need to go for the derivation of this. Directly remember R1, that is radius of first one, divided by R1 plus R2 into Q1 plus Q2. And when you have this charge on the second one after the conduction, so R2, see, in front of the Q1 dash you have R1, in front of the Q2 dash you have R2, upon R1 plus R2, Q1 plus Q2. This term in both is same. This term in both is same. So here in front of R2, this. Like, ladies and gentlemen, this question. This is the question that we have. Find the charge on each body after the conduction. Tell me, these two spheres, are they identical or non-identical? Non-identical. What is the charge on first sphere? Guys. Let's suppose this is the first sphere, this is the second sphere. So on the sphere, we say charge is Q1 dash. On the sphere, charge is Q2 dash. Now take a look. If you are supposed to find the value of Q1 dash after the conduction, okay. So we say Q1 dash is going to be R1 upon R1 plus R2. Then we say Q1 plus Q2. Now we can write over here Q1 dash will be R1. R1 is, we say, R upon R1 plus R2. R plus 2R, that is 3R. Then Q1 plus Q2. This is Q1, this is Q2. 5 plus 2 is 7. This and this will be cancelled, so it will be 7 by 3 Coulomb. So charge on the first sphere is going to be 7 divided by 3 Coulomb. Let's talk about the charge on second. Charge on second, that is going to be Q2 dash. So that will be R2 upon R1 plus R2. Then we say Q1 plus Q2. Now tell me, what is the value of R2? That is 2R. Then R1 plus R2, that will be 3R. Then Q1 plus Q2, that is 5 plus 2 is 7. This and this, 7 2s are 14. So it is 14 divided by 3 Coulomb. Is that clear? Is that clear, boys and girls? Is that clear, boys and girls? There is one more question that I have put up over here. There is one more question that I have put up over here. Is that clearer? Let me know in the chats with the fire emojis. Let me know in the chats with the fire emojis. And smash the like button if you have not liked the session yet. Because liking the session is mandatory. Extremely mandatory, I would say. Now, guys, this is an interesting question. Find the charge when A and C are touched and then B and C are touched. Okay. These are the three spheres. Identical. All the three are identical spheres. Identical spheres. Find the charge on each sphere when A and B are touched. First, see guys, how do I solve this? When A and C are touched. When A and C are touched. When this A and C are touched. Listen to me very carefully, my dear NEET aspirants. If I say A and C are touched, this is A and this is C. Okay. And charge on this is plus 2Q. Charge on this is plus 12Q. Plus 12Q. So could you please tell me what is going to be the net charge? Net charge is 12 plus 2 is 14. So 14Q. So don't you think that after the conduction, we say net charge must be 14? Yes, sir. So charge on this A, QA, must be 14. Sorry, 14 divided by 2. That is 7Q. Okay, charge on this C, it must be 7Q. Yes, sir. 7Q and 7Q. Then what does the question say? Then B and C are touched. I'll write over here. When B and C are touched. Now, my dear NEET aspirants, now you will say, sir, this C and this B are touched. But, you will have to take this C from this. Sir, see. Guys, the question is something like this. First, you are touching A and C. When you touch A and C, so charge on C will come out to be 7. Then touch this C with this B, because this is already touched with A. Don't touch these two. Don't touch these two. This one and this one. So I am keeping this B over here. I am keeping this C over here. Okay. This B and C over here. This is B and this is C. Okay. And when I say this is B, charge on this is minus 4Q. When I say this is C, charge on C, I am taking 7Q over here. I'll not take this 12Q because C is already touched with A previously. This is how you are supposed to do it. And then, my dear friends, what is going to be the net charge in this particular case, ladies and gentlemen? So you say net charge is 7 minus 4. That is 3 plus 3Q. So we say finally, this is the first one. And this is C. Finally, on this one, it is going to be 3Q divided by 2. On this, 3Q divided by 2. Okay. Why? Because net charge finally must be also 3Q. So half on this one, half on this one. Now, finally, after all these processes, finally, can I say charge on A? What is the charge on A? That is 7Q. What is charge on B? This is the final charge on B. This is C. That is 3Q divided by 2. And charge on C will be also, that is 3Q divided by 2. Ladies and gentlemen, I hope this is crystal clear to each and every single legend out there. But tell me here, is this clear? Then you have charging by conduction. Is this clear? Tell me in the chats with the fire emojis. Tell me. Okay. Now the third method is charging by induction. Second is charging by conduction. Third is charging by induction. Sir, what does this charging by induction method actually say? It is to charge a body by bringing them close to each other. It is to charge a body by bringing them close to each other. Yes, that's it. So charging by conduction means rubbing. Charging by friction means rubbing. Charging by conduction means touching. Charging by induction means just bring them close to each other. Now guys, see. Let's suppose you have a positively charged rod over here. Positively charged a rod over here. Okay. And you have got a neutral sphere. Take a look, guys. When you take this positively charged rod near to this neutral sphere, what is going to happen? We say positive charge of this rod will repel the positive charge of this sphere. Neutral sphere means the amount of positive charge is equal to the amount of negative charge. Positive charge of the rod is going to repel the positive charge of this sphere and attract the negative charge. So positive will shift to this side, negative will shift to this side. Okay, yes sir, done sir. Then you will be connecting it with the earth. This is what we call earthing. We say Earth has got ocean of electrons. Earth is an ocean of electrons. So when it is connected to Earth, Earth is going to send the electrons. Earth is going to send the electrons. When Earth sends electrons, electrons have got negative charge. Electrons are those particles which have got negative charge. And when we say protons have got positive charge. Okay. And when we say neutrons are neutral. Neutral means net charge is zero. So when you connect this body with Earth, it is going to send the electrons. So means it is going to send the negative charge. So this side will have now negative charge, which is sent from the Earth, which is sent by the Earth. Now guys, see. This positive charge will be neutralized by this negative charge. Guys, please take a look. You are bringing positively charged rod close to the sphere. It will repel the positive charge, attract the negative charge. Repel positive, attract negative. Then you connect it with the Earth by means of a wire. Then it is going to send the negative charge, electrons. These electrons will neutralize this positive charge. Okay. Now, what is going to be the final charge remaining on this sphere? What is going to be the final charge remaining on the sphere? Negative only. Why? Because this positive is neutralized. So it will become negatively charged. Negatively charged. Another method, charging of induction. See. Let's suppose you have got a rod. Previously, we took positively charged rod. Right now, let's suppose I'm taking negatively charged rod. Okay. And I'm keeping a neutral sphere close to this. Okay. So means the amount of positive charge is equal to the amount of negative charge. The amount of positive charge is equal to the amount of negative charge. Okay. So what is going to happen when you bring a negatively charged rod close to the neutral sphere? It is going to repel. The negative charge of this sphere, and it is going to attract the positive charge of this sphere. Something like this. Then what will you do is, you will bring another uncharged sphere. And you touch it with this sphere. And you bring another uncharged sphere, you touch it with this sphere. This negative is going to be transferred on this one. Because when this negative charge sees there is uncharged sphere, it is going to be transferred on this one. When you transfer this negative charge on this one, so on the previous sphere, on this sphere, what is going to be the remaining charge? Positive. What is going to be the remaining charge on this? Negative. So this will become positively charged and this will become negatively charged. I hope this is crystal and clear, ladies and gentlemen. Please tell me in the chats, is this clear? Is this clear? This is also the case of charging by induction. This is also the case of charging by induction. Oh, clear? Oh, tell me, oh, ladies and gentlemen. Okay, that's cool. Now, Coulomb's law. Guys, tell me one thing. Let's suppose you have a charge plus Q1 over here and you have a charge plus Q2 over here. There are two charges that you have. You have two charges over here. Q1 and Q2. This is plus Q1 and this is plus Q2. Tell me one thing. Will these two charges attract or repel? Obviously, sir, these two will repel. This Q1 is going to repel this Q2 with a force F. This Q2 is going to repel this Q1 with a force F. If somebody asks you, what is the force between the two charges? You say, what is the force between the two charges? I say force between the two charges. Sir, it is simple. We say two charges repel each other with a force. That force is going to be K Q1 Q2 by R square. K Q1 Q2 by R square. This is the force between the two charges. Sir. What is this K? K is what we call the Coulomb's constant. This K is what we call Coulomb's constant. Coulomb's constant. Okay. Q1 is the first charge, Q2 is the second charge, and R is the distance between the two. So from now onwards, if somebody say there are two charges, will they apply force on each other? Yes. But how much is going to be the force between the two charges? K Q1 Q2 by R square. K Q1 Q2 by R square. And value of this K is what we call 1 by 4 pi epsilon naught. So this epsilon naught is what we call permittivity. Permittivity of free space. Free space. Okay. This is what we call permittivity of free space. Guys, this is what we call Coulomb's law. Coulomb's law is simply if you have two charges, they apply force on each other. How much is going to be the force between them? That is what we call Coulomb's law. F is equal to K Q1 Q2 by R square. Okay. Yes. Okay. Now, if somebody says, sir, this epsilon naught is what we call permittivity of free space, as of now, you just remember it. So what is going to be the value of this epsilon naught? It is 8.85 into 10 raised power minus 12. We say Coulomb square upon Newton meter square. This is going to be the value of epsilon naught. Now, my dear NEET aspirants, if you put the value of epsilon naught over here, then 1 divided by 4, pi is 3.14, epsilon naught is 8.85 and 10 raised power minus 12. Then if you solve, we say value of this K will come out to be 9 into 10 raised power 9. Then we say Newton meter square upon Coulomb square. Newton meter square upon Coulomb square. This is going to be the value of K in that particular case. Okay. 9 into 10 raised power 9. So from now onwards, my dear friends, if somebody says what is the force between the two charges, F is equal to K. K will be 1 by 4 pi epsilon naught. We say Q1 Q2 by R square. Q1 Q2 by R square. This is the force between the two charges. This is the force between. And this is Coulomb's law. Coulomb's law tells us how much is going to be the force between the two charges. Okay. Okay. Yes. Now, my dear friends, if you take these two charges away from each other, sir, what is going to be the force between them? Force is going to decrease because force is inversely proportional to R square. So if we make the graph between F versus R, okay, it is going to be a rectangular hyperbola. Why? Because force is inversely proportional to R square. Force is inversely proportional to R square. Okay. Yes. Now, one thing I would want you guys to remember. What is that? Guys. See. If you have, let's suppose, two vectors. This is F and this is F. Force F, force F. Or. See guys. Let's suppose you have a block over here. You have a block over here. On this block, we say forces acting from this side, forces acting from this side. Equal and opposite. So what is going to be the angle between these two forces? What is going to be the angle between these two forces? 180 degrees. So could you please tell me what will be the net force? Sir, this force will be cancelled with this force. Net force is 0. Because when two forces are equal and opposite, net force is 0. Let's suppose if you have a body. On this body, we say two forces are acting in the same direction. What is going to be the net force in that case? That will be 2F. F plus F is 2F. If on a body, forces acting in the opposite direction, theta is 180, then net force is 0. Here, what is going to be the value of theta? 0, because angle between this F and this F is 0. This is 2F. Now, if I say there is a box over here, on this box, we say forces acting from the upper side, forces acting from the lower side. This angle total, this is 90 degrees. We say when the angle between the two vectors is 90 degrees. In that particular case, if you say what is going to be the net force, sir, net force in that case will be root 2F. Root 2F. Sir. If you have two forces, F and F, which are acting at an angle of 60 degrees, in that particular case, we say net force is going to be root 3F, root 3 of F. Now, guys, if you have two forces acting at an angle of 120 degrees, okay, like this is a box, on this box, two forces are acting at an angle of 120 degrees. This angle is 120. So resultant in that particular case, net force in that particular case will be F. Oh my goodness, sir. Amazing, sir. Sir, can you prove any one over here? Yes. Let's prove this one. Take a look, guys. Let's prove this one, guys. Let's prove this one. Let's suppose, my dear friends, you have a block over here. On this block, force is acting in this direction. Force is acting in this direction. Theta is equal to 90 over here. Whenever you have two vectors, you have to find the resultant between the two forces. You use this formula. Under root of F1 square plus F2 square plus 2 times of F1, F2 cos of theta. Theta is the angle between the two forces, two vectors. So this is going to be under root of, what is the value of F1? That is F square plus F square plus 2 times of F into F becomes F square. Then we say cos of 90. Cos 90 is 0. So this term is going to become 0. So what will be here? That is F square plus F square. This F square plus F square is going to be 2F square. Okay. Now this square and root will cancel, but for 2 it is going to remain. So it will be root 2 of F. That is what I said. That is what I said. Okay. So directly you will be remembering, if angle between the two vectors is 0, resultant is 2F. If angle between two vectors is 180, resultant is 0. At 120, resultant is F. At 60, resultant is root 3F. At 90, resultant is root 2F. Now, if let's suppose you have F1 and F2, then in that particular case, we'll be using, if this is different, this is different. Okay, not F and F, different, F1, F2. In that case, you will be using this general formula, which I have told you. But tell me in the chat, sir, if this is clear. Tell me. Clear? Smash the like button if you are not liked the session yet. Okay, that's great. Now, guys, first question. Let's suppose if I say you have got a square over here. Okay. So plus Q, plus Q, plus Q, plus Q. These are the charges present at the corners. What is the net force on the center charge? What is the net force on the center charge? That is what you are supposed to find out. Guys, see, listen carefully. In this particular case, we say you have to find net force on this one. On the center charge, this will also apply force, this will also apply force, this will also apply force, this will also apply force. This is going to apply the force in this direction. Let's suppose that is F. Okay. This will also apply the force on this in the opposite direction with F. Why, sir? Because this will repel this in this direction. This will repel the center charge in this direction. This one is going to repel in this direction with the force F. This one is going to repel in this direction with the force F. So this is going to cancel with this. This is going to cancel with this. So what is going to be the net force on the center charge? That is 0. Take a look at this. Take a look at this. This is an equilateral triangle. Now guys, due to this plus Q charge on the center charge, force is going to be this. Due to this plus Q on the center charge, force is going to be this, that is F. Due to this charge, force on the center charge, it is going to be this F. Now guys, I'm making it over here. I'm making it over here. This is plus Q center charge. So on this center charge, one F is in this direction, another F in this direction, another F in this direction. Now guys, see. Always remember, in case of an equilateral triangle, this is 120 degrees, this is 120 degrees, and this angle is also 120 degrees. Total is 360. Now, if I say angle between this F and this F, this is 120. So whenever you have two forces, angle between the two forces is 120. Here it is mentioned. What is the resultant? F. So resultant of this F and this F, it is also going to be F. Now, I'm making it over here. This is plus Q. Okay. On this plus Q in the upward direction, you have now F. You have downward direction F. Now, ignore this and this. Now, this F and this F is opposite. What is going to be the net force? That is 0. Now, guys, directly remember. If identical charges are present at every corner, identical charges means if Q plus Q is here, plus Q is here, plus Q is here, plus Q is here. This is what we call identical charges. If identical charges are present at every corner, then net force is 0 at the center charge. Net force on the center charge will be 0. See here. Even in this particular case, you check plus Q, plus Q, plus Q, plus Q, plus Q. We say net force on the center charge is going to be 0. Even in this case, net force on the center charge is going to be 0. What is the condition? Condition is charge must be present at every corner and identical charge must be, similar charge must be present at every corner. This is the condition. That's it. Take a look at this question. Tell me. Find the net force on the center charge. Will it be 0? Do you think it is going to be 0? No, sir. Why? Because identical charge is not present. Plus Q minus Q. Take a look, guys. How do I solve this question? How do I solve this question? See, we say due to this Q, charge on this will be in, force on this will be in this direction, away from the charge. Okay. Due to this plus Q, it is also going to repel away from the charge. This minus Q is going to attract this charge with a force F. This minus Q is going to attract this charge with a force F. Now, my dear NEET aspirants, you take a look over here. This is plus Q. On this plus Q, we say one force is acting in this direction. This is plus Q. One force is acting in this direction. Guys. This is F and F in the same direction. When you have F and F in the same direction, F plus F is 2F. Now this 2F. Here this is 2F. F plus F is 2F. Now tell me, how much is this angle? This angle is 90. Always remember, in case of a square, this is 90. Now, my dear NEET aspirants, if you have angle between the two vectors as 90, what is the resultant? Root 2F. If this is F, this is F, this is root 2F. If this is X, resultant will be root 2X. If this is 2F, this is 2F, resultant is going to be root 2 of 2F. So in this particular case, what I can say, the net force over here is going to be net of this and this. This is 2F, this is 2F. That is going to be a root 2 of, I would say, 2F. That is going to be 2 root 2F. Tell me, is this clear? Is this clear, or give me the signal in the chats? Then only I'm moving. Now, guys, can I see, please listen to me very carefully. If this is a square, okay, let me just tell you over here. If this is a square, if this is side A, what is the diagonal of the square? What is the diagonal of the square? This is going to be a root 2a. If somebody says, what is half of the diagonal? Half of the diagonal, always remember it is a divided by root 2. Half of the diagonal is a by root 2, complete diagonal is root 2a. One more thing. If this is a equilateral triangle, if this is side A, this will be also A, this will be also A. And if somebody says, sir, what is going to be this distance from center to the corner? From center to the corner, this is going to be A divided by root 3. A divided by root 3. Now come over here. Now, in this particular case, my dear NEET aspirants, if I say, what is F? F is the force which this Q is applying on the center charge, or which this Q is applying on the center charge, or which this Q is applying on the center charge, which this Q is applying on the center charge. So can I write the exact value of F? So this 2 root 2 and this F will be force between this charge and this charge, or force between this charge and this charge, or force between this charge and anything, bro. So this distance is going to be, if the side is, let's suppose A, this is going to be A divided by root 2, half of the diagonal. So can I not say force between this and this, that is K, Q into Q is Q1, Q2, that is Q square, divided by, what is the distance between the two? That is going to be A divided by root 2. Oh, yes or no? Yes or no? Okay. So in this particular case, if I say what is the force between these two, sir, K, Q1, Q2, and it is square, sorry. Because K, Q1, Q2 by R square. Yes, sir. So further we can write it 2 root 2 K Q square divided by A square by 2. A square by 2. Now this 2 is multiplied to this 2 because it will come in the numerator. 2 into 2 is 4. So it will be 4 root 2 K Q square divided by A square. This is the complete answer to the question. Oh, tell me in the chat, so. Clear? 3-point charges plus Q and minus Q are placed at the corners of an equilateral triangle. Okay. 3 charges, it says plus Q, then it says plus Q, and then it says minus Q are placed at the corners of an equilateral triangle of side A. Another charge plus Q, capital Q, it is placed at the centroid. Okay. Force on this, we have to find force on the center charge. Sir, will it be 0? No, it will not be 0. Why? Because the charges are not identical. Now see, this plus Q is going to repel this plus Q in this direction with the force F. This plus Q is going to repel this charge in this direction with the force F, because positive repel. This minus Q is going to attract it in this direction with the force F. Now see, what is this angle? 120. Tell me, guys, if angle between this F and this F is 120, so what is the resultant of this and F? This F, that is F only. Oh, yes, sir. Now, guys, tell me. What is the net force? See, resultant of this F and this F is F. Already one F was over there. So F plus F is 2F. So what is going to be the net force in this particular case? That is 2F. Now let me write the value of F2. What is F? F is force between any two charges, between this and this, between this and this, between this and this. Yes, sir, how can we write? That is K Q1, Q2, small q, capital Q, divided by, what is the distance between the two? A divided by root 3. I told you recently, its whole square. Now, guys, see. So this is 2 KQQ divided by A square divided by 3, because root and square will cancel. 3 into 2 is 6. 6kqq divided by a square. Is this question clear? Oh, tell me guys, please, please, please. Everyone means everyone. Tell me quickly in the chats. Give me 30 seconds, I'll come. 30 seconds. Clear? Now, guys, let's move on to the next question. Next question is this. Next question is this. Find the net force on 2 Coulomb charge. See, guys, this is a square. You have got 2 Coulomb charge, minus 2 Coulomb charge, 4 Coulomb charge, minus 2 Coulomb charge. You have to find net force on this one. See, this minus 2 Coulomb is going to attract it towards itself with a force F1. Let's write this force F1. What is the value of F1? F1 is K Q1 Q2 by R square. K means K. What is the value of Q1? That is 2. What is the value of Q2? That is 2 divided by R square. What is the distance between the two? That is 2 square, because side is 2. So 2 into 2 is 4. 2 into 2 is 4. So it will come out to be K. Okay. Yes, sir. Let's find the value of F2. F2 is the force between this and this. Minus 2 Coulomb is going to attract this towards itself with a force F2. So this F2 will also come out to be K. Q1 is 2, Q2 is 2. Sir, if we have a negative charge, are we supposed to take this positive? Yes. When you find the magnitude of the force, you are finding the magnitude right now only, not the direction. Direction we find in vector form. There we'll take the negative side. Right now take positive. So 2, another is 2 divided by 2 square. This and this will cancel, so it will come out to be K. Okay. Now, guys, this 4 Coulomb is going to repel it. Okay. With a force, I would say F3. Let's find the value of this F3. F3 is K. Q1, Q2. Value of Q1 is 2. Value of Q2 is 4 divided by R square. Distance between the two charges 2 root 2. Because this is the diagonal, its whole square. Now 2 into 2 is 4. 2 root 2 whole, 2 into 4 is 8. 2 root 2 whole square is also 8. This 8 and this 8 will be cancelled, so it is K. Okay. Now guys, see. Let's draw this. This F1 comes out to be K. This F2 comes out to be K. F3 comes out to be K. So can I not say in this particular case, this is F1 that is K. This is F2 that is K. This is F2 that is K. And this is F3 that is K. So this one and this one have the resultant of, when you have K and K at an angle of 90, its resultant is root 2K. Now, resultant of this root 2K and this K, that is going to be the net force. Guys, see. This and this are in the opposite direction. If this was also K, this was also K, then I would have said 0. But this is greater than this one. So it is going to be root 2K minus this K. So this is going to be, take K common. It is going to be root 2 minus 1. This is the answer. K root 2 minus 1. Is it clear? Because it is root 2 times of K. Obviously, it is greater than K, na? Root 2 times. Tell me the answer of this question. Tell me the answer of this question. Okay. Oh, it is simple. Oh, this is K, F1. This is F2 is K. This is F3 is K. Now, this F1 and F2, they are identical. And angle between these two is 90. So, what is the resultant of this one and this one? That is root 2K. Because if this is F, this is F, this is root 2F. Now, leave this one and this one. Take this K and this K. Their resultant will be, their net will be root 2K minus K. This question I am giving you as homework. Okay. This question I am giving you as homework. This question I'll show you over here. A charge Q is divided into two parts, Q and Q minus Q. See guys, there is this charge. It is divided into two parts. First is Q. What is going to be the rest? That is Q minus this Q. If this is 10, this is 5. So 10 minus 5, this will be 5. How should Q and Q be divided so that Q and Q minus Q placed at certain distance experience the maximum force? Now guys, what does it say? It says that what should be the value of this Q? Guys, to find Q, or how this charge should be divided. Okay. So that, to find Q, so that this force between the two, force between them is maximum. Force between them is maximum. Now see. Now guys, take a look. How is this possible? The force is maximum. See, if you have to find the maximum of any quantity, let's suppose you have quantity y. If I say, what is the maximum value of y? You will say, sir, maximum value of y will be when its dy by dx is 0. Please remember it directly. This is the concept of maxima and minima. This we have studied, covered over there only. If there is a quantity, if you want to find its maximum or minimum value, you do its differentiation and make that differentiation equal to 0. Then you will find the maximum and minimum. So at maximum and minimum value of y, its differentiation will be 0. Similarly, if you have to find the maximum value of force, means differentiation of force with respect to charge, it must be equal to 0. So dF by dQ will be 0, then only force will be maximum. This is the concept. Okay. If it is difficult for you to understand, you can ignore this question. Now, guys, take a look. Now, fine. Let's find the force between the two. Forces between this and this, that is K. What is the value of Q1? That is Q. What is the value of second charge? That is Q minus Q divided by, what is the distance between the two? Let's suppose that is R. So it is R square. Distance between them is R square. Now, guys, in this particular case, this is going to be K divided by R square. Take this out. Now, this is Q into this Q minus Q into Q is Q square. Okay. Now, guys, what I can write over here, dF divided by dQ. Differentiation of force with respect to charge. Means you are supposed to differentiate this. Sir, K divided by R square is constant, so take this out. Now, differentiation of Q into this capital Q with respect to Q only. So, differentiation of this will come out to be capital Q. It is like, what is the differentiation of 4x? That will be 4 with respect to x now. Similarly, differentiation of QQ, it will be capital Q minus. What is the differentiation of Q square? That is 2Q. Power down, power minus 1 and make it equal to 0. So, because force will be maximum only when differentiation of force will be equal to 0. Now, this term is equal to 0. So, take this over here, it will be 0. So, Q minus 2Q is equal to 0. So, take it over here. So, Q will be equals to 2Q. So, can I not say this Q will be equals to Q divided by 2? So, means how should you distribute this? So, this Q you are supposed to divide in Q divided by 2. Okay, capital Q by 2. This will be also capital Q by 2. Then only force will be maximum. Tell me, is this question clear? Is this question clear? Now, guys, percentage questions. NEET 2019. Take a look, guys. 2-point charges A and B having charge plus Q and minus Q respectively. You have got two charges plus Q and you have got another charge minus Q. This is plus Q and this is charge minus Q. Okay. Are placed at a certain distance apart. Let's suppose distance between them is, let's suppose R. And force acting between them is F. Force between them is F. So this F will be equals to K. Q into Q is Q square divided by R square. If 25% charge of A is transferred to B. Now, guys, finally, what does the question say? 25% of charge is transferred to this. Listen carefully. If 20, guys. If I say this is Q, how much Q? 100% Q or 70% Q? No, otherwise I would have mentioned 70% Q. It is 100% Q. So if you are transferring 25%, how much is going to be the remaining 75%? So we say QA is going to be 75% of Q. Because previously it was 100%. Now you have transferred 25%, so 70% is the remaining. Now, guys, see. When it comes to QB is how much? We say negative of minus 100% of Q. Negative 100%. And you are adding positive 25%. Positive 25% of Q. Sir, minus 100% plus 25%. It is going to be minus 75% of Q. Oh, sir, amazing. This is QB. Yes, sir. Now, in this particular case, if I say what is the value of QA, 75%, we can write it like this: 75 divided by 100. 35% we can write 35 by 100. 20% we can write 20 by 100 into this Q. 25 threes are, 25 fours are. So this comes out to be 3 by 4 Q. When it comes to this will be minus 75 divided by 100, and this is Q. So threes are, fours are. So this will be minus 3Q by 4. This is the final charge. Then, my dear friends, you are supposed to find the force between the final two charges. Now, what is F dash? F dash will be K. What is the value of Q1? Finally, force will be, sir, finally charge is 3 by 4Q. Another charge is 3 by 4Q. Okay, divided by, we say, R square. So this is going to be 3 into 3 is 9. 4 into 4 is 16. 9 divided by 16. Then we say this is K. Q into Q is Q square divided by R square. This is F dash. Now tell me F dash will be 9 by 16. 9 by 16, KQ by R square, Q square by R square. That is 9 divided by 16. Instead of this, I'll keep F. So this is the final force. Can you solve this question? Force between the two identical spheres with the same charge is F. You have got charge plus Q. You have got another charge plus Q. Distances R. Force between the two is KQ square by R square. That is F. If 50% of charge is transferred from one sphere to the other sphere, then new force will be, guys, it says 50% of this charge is transferred. 50% of Q is transferred to B. How much is going to be the remaining charge of A? Sir, 100 it was, 50 is transferred, it is going to be 50%. And when it comes to B, already it was 100% positive charge. Now 50% more positive charge is added, so it is going to be 150% of Q. Now guys, if I say QA, this is 50%. 50% means 50 divided by 100 Q. 0, this 5 ones are, 5 twos are. So this is going to be Q by 2. So this is going to be 150 divided by 100 into this Q. This 0, 5 threes are 15, 5 twos are 10. This is 3 by 2Q. This is the final. Now what is the finally force? F dash is going to be K. Q1. Finally Q1 is Q by 2. Q2, 3 by 2Q divided by R square. Now this is going to be 3 divided by 4, 3 by 4, K. Q into Q is Q square divided by R square. Now F dash is going to be 3 divided by 4. KQ by R square. Instead of KQ by R square, it is F 3 by 4F. Is this clear? Okay. Now, guys, vector form of Coulomb's law. Let's talk about the vector form. Guys. If I say, what is the see, guys, take a look. Let's suppose you have Q1, Q2, distance between the two charges R. Okay. Now, my dear NEET aspirants, let's suppose if the value of charge is 2 coulomb, Q1, if the value of Q2 is 4 coulomb, if the value of R is 2 meters, if I say what is the force between the two, you say sir, force between the two is K, Q1, Q2 by R square. Sir, K is K, 9 in 10 raised power 9, Q1 is 2, Q2 is 4, R is 2. Simply you can use this formula. What if I say the question is like this? Q1 is 2 coulomb, Q2 is 4 coulomb, and this R, it is given as 2I cap plus 4J cap. Find the force between the two charges. Sir, will you still use this particular equation? F is equal to K Q1 Q2 by R square? No. Why? Because here it is given in the vector form. For that, we are using this particular equation. F is equal to K Q1 Q2 divided by R cube into R vector. Divided by R cube into R vector. Now, my dear NEET aspirants, listen to me very carefully. Example. See. Let's suppose if I say Q1 is 2 coulomb, R is given as 2I cap plus 3J cap, and this Q2 is given as 4 coulomb. What is the force between the two? You say force between the two is K Q1 Q2 divided by R cube, okay, into R vector. This is how you are supposed to find out. Now, guys, in this particular case, what is the value of this R vector? That is 2I cap plus 3J cap. If I say what is the magnitude of this, that is going to be, how do you find the magnitude of any vector? That is under root of this 2 square plus I would say this 3 square. So this is going to be under root of 2 square is 4, 4 plus 3 square is 9 plus 4 is, we say root 13. So value of R comes out to be root 13. Now tell me what is going to be the force. Force is K. What is the value of Q1? That is 2. What is the value of Q2? That is 4 divided by R cube. R is, I would say, root 13 whole cube. This is basically magnitude of R. And this R vector, instead of R vector, you'll be writing 2I cap plus 3J cap. This is going to be the answer. You can further simplify it also, but this is going to be the answer in this case. This is how we are supposed to use the vector form. Like, take a look at this question. Guys. If I say find the force on 2 coulomb charge, you are supposed to find the force on 2 coulomb charge. In this particular case, what is the value of R? That is 3I cap plus 4J cap. 3I cap plus 4J cap. Okay. And can I say if this is value of R? What is the value of mod of R? That is going to be under root of 3 square plus 4 square. Okay. So that is going to be, I would say, 3 square is 9 plus I would say 16. That is going to be root of 25. That will be 5. Now, if I say, what is the force between the two? Force will be K Q1 Q2 divided by R cube into, I would say, R vector. This force will come out to be, this is in the vector form. So K is K. What is the value of Q1? That is minus 2. Guys, whenever you have the question in the vector form, in that particular case, you are supposed to take the charge along with the sign. Then into, what is the value of this? That is 2 divided by R cube, that is 5 cube, into R vector. R vector is basically 3I cap plus 4J cap. So what can I write over here? This is going to be 2 into 2 is 4. So minus 4K. Then you say this is 3 or directly 2 into 2 is 4. 4 into 3 is 12. So it is going to be K. Then I would say 12I cap. Then 4 into 4 is 16J cap divided by 125. This is going to be the answer in this case. Okay, this is the answer in this case. But you can simplify it further also. 2 into 4 is 8. 8 twos are 16. 8 threes are 24. That's it. Simple simplification. You can do it from your end. So this F is going to be, this is K. 2 fours are 8. 8 twos are 16. 16 I cap plus 8 threes are 24 J cap divided by root 13 whole cube. Keep it like this. Let's suppose you have one more question. Yes, you have to consider the negative sign also. Okay, you have to consider the negative sign also when it comes to the vector form. See guys. Find the force applied by 2 Coulomb charge which is at, listen to me very carefully. This is an important question. This is y-axis, this is x-axis. Find the force applied by 2 Coulomb charge which is at, let's suppose you have got 2 Coulomb charge over here, which is at, I would say 2, 3, 4. These are the coordinates of a charge 2, 3, 4. On 5 Coulomb charge, there is one more charge over here, that is 5 Coulomb, which is at 5, 7, 9. These are the coordinates of this. This is a very good question. Find the force applied by 2 Coulomb charge on 5 Coulomb charge. Coordinates of this and this. Guys, see. If I say what is the position vector of this, position vector will be mentioned in this one, like this, R1. Position vector of this will be R2. Position vector basically tells you where the object actually is with respect to the origin, So from the origin, you take an arrow, something like this. From the origin, you take another arrow, something like this. This is R1, this is R2. So if I say position vector R1, what is the value of this R1? So it is 2, 3. This is x coordinate, y coordinate, z coordinate. So it is going to be 2i cap plus 3j cap plus 4k cap. So if I say this is the position vector of a charge, that means x coordinate of this charge is 2, y coordinate is 3, z coordinate is 4. Similarly, if I say position vector R2, it is going to be, that is 5i cap plus 7j cap plus 9k cap, something like this. Amazing, sir. Amazing, sir. Now, guys, what does the question say? Find the force by 2 Coulomb charge on, which is at this, on 5 Coulomb charge. How much force this 2 Coulomb is applying on this one? If this is the force applying on this, then you have to make the separation between the two are something like this. Sir, what if the question would have been something like this? Find the force applied by 5 Coulomb charge on 2 Coulomb charge. Then the arrow would have been something like this. This is important. If I say force is 2 Coulomb is applying on 5 Coulomb, then the radius vector has got this direction. And if I say, how do you find the value of this R? This R is going to be R2 minus R1. Sir, what if this was applying force on this? Then R1 minus R2. Now tell me R2 minus R1. How do we find? 5 minus 2. That is going to be 3i cap. I minus I, j minus j, k minus k. 7 minus 3, 4j cap. 9 minus 4, 5k cap. This is going to be the position vector. Sorry, this is going to be the separation between the two. Now, if I say what is the magnitude, that is going to be under root of 3 square plus 4 square plus 5 square. So it is going to be under root of, this is 9 plus 16 plus, I would say, 25. 9 plus 16 plus 25. Okay. Okay. So this is going to be root 50. Root 50. 16 plus 9 is 25. 25 plus 25 is 50. Now, if I say force, now you can apply the force. F is equal to force on 5 Coulomb charge. That is K, Q1, Q2 divided by R cube into R vector. Now, keep the K as it is. What is the value of Q1? That is 2. What is the value of Q2? That is 5. Divided by R cube. R cube is going to be root 50. I would say whole cube. into R vector. R vector in this particular case is going to be, this is the value of R vector. That is 3I cap plus 4J cap plus 5K cap. You can further multiply it. 5 2s are 10. So 10 and 3 is 30. I cap plus 40J cap plus 50K cap divided by root 50 whole cube and take this K out. This is going to be the force. Oh, tell me in the chats if this is crystal and clear. Everybody out there. Smash the like button if you have not liked the session yet. Now guys, relative permittivity. What does relative permittivity actually say? Listen to me very, very, very carefully. I'll make you understand this relative permittivity. This is an important topic. I'll make you understand this in a simple way, in a simple and in a crisp way, in a beautiful and in a nice manner. You are going to love it. You are going to love it. That is for sure. Okay? Yes. Guys, see. This is, let's suppose there are two charges we have. Separation between the two charges are, and these two charges are kept in air. This medium over here is air. If I say what is the force between the two charges, you say force between the two charges, let's suppose F. You say force between the two charges, let's suppose F. Force between Q1 and Q2 in air is F. Okay. Now, if you are keeping this in medium, in a medium, any medium, water, oil, whatever it may be, same two charges at similar distance, we say force between the two charges in medium. Medium means air, any other medium. Sorry, medium apart from air, water, air, oil, something like that. Now, here, this is what we call force in a medium. Let's suppose here, we call this as F naught, force in air. Now, guys, see. In air, we say force is F naught. In this medium, this force will be, listen carefully, whatever is the force in air divided by epsilon R. Oh, sir. This epsilon R is what we call the relative permittivity. So means, can I say, this relative permittivity helps us to find the force in a medium? Absolutely, yes. Because if I say, you know, force in air, you know, relative permittivity of a medium, like for water, it is 81. So you say F naught divided by 81. Okay. Like, let me just give you an example. If the force between two charges in air is 1000 Newton, then find the force between them in water. Then find the force between them is water. And relative permittivity for water, ER for water is 81. For every, I would say, for every medium, it has got relative permittivity. Relative permittivity of different mediums is different. So can I say, sir, force in any medium, like in water, we say force in air divided by relative permittivity? Yes, sir. So force in a medium is going to be, what is the force in air? That is 1000 given, divided by 81. Oh, done and dusted. So can I say this relative permittivity ER, this ER, this ER, epsilon R, helps us to find force in a medium. It helps us to find force in a medium. And one more important thing I just want to mention over here. One more important thing I just want to mention over here. What is that? What is that? That is, we say, this epsilon of a medium is equal to epsilon R divided by epsilon naught. Sir, what is this? What is this? See. In this particular case, this epsilon, this is called permittivity of a medium. Permittivity of a medium. And this epsilon naught is what we call permittivity of free space. And this epsilon R is what we call, that is, relative permittivity. So basically, permittivity in nutshell tells you how much is going to be the force between the two charges in any medium. Permittivity tells you the force. Now guys, see. We said different mediums have got different permittivity. This is the permittivity of its own medium. And this is permittivity of free space, 8.85. Permittivity of, I would say, air, 8.85 in 10 raised power minus 12. And this is the relative permittivity. Now guys, let's suppose, listen carefully. For water, could you please tell me what is the value of relative permittivity for water? You say, sir, it is 81. And what is the value of epsilon naught? 8.85 into 10 raised power minus 12. Now, if somebody says, find the permittivity, of water. Permittivity of water, not relative permittivity. You say simply, sir, permittivity of water, epsilon of W, it is going to be epsilon naught into relative permittivity, because this is the formula. Permittivity of any medium is going to be relative permittivity into permittivity of free space. So this is going to be, what is the value of epsilon naught? 8.85 into 10 raised power minus 12. Multiply it with 81. So whatever this value comes out to be, that is going to be the permittivity of medium. So can I not say this relative permittivity also helps us to find permittivity of any medium? Yes. Why? Because if you know the relative permittivity, you multiply it with epsilon naught, you'll get the permittivity of that medium. So relative permittivity has two functions. First is, it helps you to find force between the two charges in any medium. Second, it helps you to find permittivity of any medium. Guys, tell me in the chats quickly if this is crystalline clear. Tell me in the chats quickly if this is crystalline clear. Quickly, guys. Now, take a look here. Take a look over here. When air is replaced by a dielectric medium of force constant K, dielectric constant is also what we call the relative permittivity. What does the question say? Let's suppose you have two charges, Q1 and Q2. These are placed in air. Okay. And let's suppose force between the two is F. Now it says that when this air is replaced with a dielectric medium, with some other medium, which has got force constant K, which has got relative permittivity K. It is not given 81, it is given as K. Okay. Then the maximum force of attraction between the two charges. What is going to be the force of attraction between the two charges? Oh, tell me, oh, sir, force in this medium is going to be force in air divided by relative permittivity. So that is going to be force in air, that is F, divided by relative permittivity of this medium is K, F divided by K. What does it mean? What does it mean? So means force here has decreased by K times because it is divided by K. F divided by K means force is decreased by K times. So decrease K times, increase K times remains same by K square, option A. Yes, it decreases by K times. I hope now this is crystalline clear. This was the question from NEET 2020. Now equilibrium position. Take a look, guys. Equilibrium position. Equilibrium position. Let me make you understand this topic. What does equilibrium position mean? Let's suppose you have a charge Q1 over here. You have a charge Q2 over here. Let's suppose I ask you, tell me the position. Tell me the position where net force on the third charge is 0. See. Let's suppose I'll place the third charge over here. Sir, will the third charge net force be 0 on at this point? Let's check. This is positive charge. This is also positive. This positive charge will repel this positive charge in this direction. This positive charge is also going to repel this positive charge in this direction with a force F. Let's suppose this is F1 and this is F2. This positive is repelling. That positive is also repelling. This is the third charge. Tell me, these two forces are in the same direction. Do you think net force is 0 over here? Net force cannot be 0. Net force will be only 0 when the two forces are in the opposite direction. If you place over here third charge, this is going to repel. That one is also going to repel. Here also net force is not equal to 0. Now, where am I supposed to place the third charge? See, guys, this is Q1, this is Q2. Let's place the third charge in between the two charges, not from the outer side. This Q1 is going to repel it in this direction with F1. This Q2 is going to repel it in this direction with F2. Now, this F1 will be cancelled with this F2 because they are opposite and equal. So, net force will be equal to 0. Okay. Now, net force is 0 on this charge from the inner side. At what distance? At a distance of this distance is going to be x from the smaller charge. Okay. So, we say net force is 0 on Q naught at x distance. So at x distance, net force on the third charge is 0. If somebody asks you what is the value of this x, r upon under root of n plus 1. Simple. R means this r. Okay. Okay. R means this r. And what does n actually mean? Listen to me very carefully. What does n actually mean? See, guys, if the question is, let's suppose this something like this. This is q and this is n times of q. This is n over here. This is n over here. Okay. So, my dear NEET aspirants, if you have two charges q and n times of q, or this is q1, this is q2, where should I place the third charge so that net force on it is 0? Sir, in between the two charges. Sir, exactly at the midway? No, near to the smaller charge, at x distance. X will be r upon under root of n plus 1. N means how many times this charge is bigger than this charge. N means how many times this charge is bigger than this charge. That's it. Take a look at this point. Find the position where net force is 0. This is Q, this is 9Q, this is there. In this case, could you please tell me what is the value of N? N is 9. Sir, how can we find it? See. Always you can find bigger charge, 9Q, divided by smaller charge. This and this will be cancelled, N will come out to be 9. Sir, at what point, at what distance we need to place Q naught over here? At what distance? X. So, X will be R upon under root of N plus 1. At x distance, we say net force on the third charge is 0. So R is going to be 10 upon under root of n. That is going to be root 9 plus 1. So that is going to be 10. Root 9 is 3. 3 plus 1 is 4. 10 by 4, that is 2.5. Oh, done, sir. Done, sir. 2.5. Now, guys, let's suppose this one. Sir, where should I place the third charge? Sir, here, in between the two charges at x distance. So what is the value of this x? X will be R upon under root of n plus 1. Sir, how do I find n over here? N in this case will be bigger charge by smaller charge. That is 36q. 36q divided by 25q. Q and Q will cancel. So this will be 36 divided by 25. Sir, shall I divide it or I'll keep it as it is? See. Take a look here. 36 is a perfect square. 25 is a perfect 5 into 5, 6 into 6. So if you keep it as it is, here it is root, it is going to help. Now see, R means 11. Don't divide over there. Under root of n. Instead of n, I'll be writing 36 divided by 25. Why did I keep it as it is? Now root 36 is 6, root 25 is 5 plus 1. 11 upon 6 by 5 plus 1. 6 divided by 5 plus 1 is equal to 11 upon 5 into 1 is 5. 5 plus 6 is 11. 11 divided by 5. Yes or no? So now it is going to be 5 into 11 is 55 divided by 11. Yes or no? Is this clear? So this is going to be 5 meters. From the smaller charge. Now, if somebody says from the bigger charge, what is going to be the distance? See. From this is 25q. Okay, this is 36q. So here, from here to here, x is coming out to be 5. Total R is 11. If I say from the bigger charge, this is going to be the distance. Okay, so that is going to be total 11 minus 5. Okay, that is going to be 6. Tell me in the chats if this is clear to each and every single student out there. Okay. Yes. Is this clear? Yes. Okay. Yo, it is very cold here. So I have to wear a heavy jacket. Just a second. Now, guys, take a look. Let's suppose if the two charges are of opposite nature. If the two charges are of opposite nature. If the two charges are of opposite nature. Like you have got plus q, you have got minus n times of q, and distance between them is r. Guys, see, this was the case where both the charges are of same nature, positive, or we say negative. In that case, this is going to be the answer. when the two charges are of opposite nature, plus q minus q. In that particular case, you need to place the third charge at this distance, x distance, but from the outer side. Listen to this very carefully. If the two charges are of same nature, then the third charge will be from the inner side. Okay. If the two charges are of opposite nature, then the third charge will be from the outer side at x distance. And this x in this particular case will be r upon under root of n minus 1. That's it. Under root of n minus 1. Okay. Yes. Let's suppose the question is, you have got plus q minus 4q. Okay. You have got plus q and minus 4q. And distance between the two is, let's suppose, 6 meters. Where should you place the third charge so that net force on it is 0? Sir, from the outer side. At what distance? X distance. If you ask me what is the value of this x, r upon under root of n minus 1. So you'll be saying r is 6, under root of n, root n, that is 4 minus 1. So that is going to be 6 divided by root 4 is 2 minus 1 is 3. 3 ones are 3 twos are 6. So this is going to be 2 meters. Now, this is 2 meters from the smaller charge. If I say from bigger charge, it is going to be, from bigger charge, it is going to be 6 plus 2. That is r plus x. That will be 8 meters. I hope this is crystal clear to each and every single student. If Q1 and Q2 are unlike charges opposite in nature, then net force will be 0 at what distance? Then net force will be 0 at what distance? Take a look. Let's suppose you have got over here plus Q and minus Q. In this particular case, we say x will be r upon under root of n minus 1. Net force is equal to 0 at r upon under root of n minus 1. How do you find n over here? Guys. N will be bigger charge by smaller charge, but here it is same. Q divided by Q, that is coming out to be 1. Now guys, in this particular case, it is going to be r upon root n is root 1 minus 1. Root 1 is 1, 1 minus 1 is 0. So anything by 0, it is infinite. So in this particular case, we say net force will be equals to 0 on the third charge at what? Infinity. At infinity. If the two charges are equal and opposite. I hope this is crystal and clear. Okay, this will be doing from your end. This is homework. Okay. Magnitude of third charge Q naught. Let's suppose, my dear friends, you have two charges plus Q and n times of Q. That third charge, till now I was saying, sir, where should I place the third charge? From the outer side, from the inner side. Now, if somebody says, what is the value of that third charge? Magnitude of that third charge. Okay. Magnitude of third charge, if system is unique, if all the three charges are in equilibrium. 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 Now guys, see, when we say this third charge Q naught, the value of this third charge Q naught is minus n times of Q upon under root of n plus 1 whole square. This is the magnitude of third charge. What should be the magnitude of the third charge? So that the system, all the three charges in equilibrium, means simply it is asking the magnitude of third charge. minus n times of q under root of n plus 1 whole square. Take a look over here. There is a question which was asked in NEET 2013. A charge q is placed at the center of the line joining the two charges. These are the two charges, and this is the third charge placed over here. The system of three charges in equilibrium if q is equal to, you have to find the value of third charge. What is the value of third charge? Minus n times of q upon under root of n plus 1 whole square. What is the value of n over here? Guys, value of n in this case is this q divided by q, that is 1. So can I not say this q will be equals to minus n times of, sorry, this is instead of q, let's say 1 times of q upon. Then we say under root of n plus 1 whole square. That is root 1 plus 1 whole square. So this q will come out to be, this is minus q divided by, root 1 is 1, 1 plus 1 is 2, 2 square is 4, q divided by minus q by 4. Clear? Oh? Okay. Now one more question over here is, a particle of mass m carrying a charge minus q is moving around q2. Okay. This is a charge q2 placed at the center. And there is another charge which is revolving around this. Okay. This is q1. Revolving around this. Let's suppose it has velocity v. It is revolving around this charge which is at r distance, and it is minus q1. And its mass is m. A particle of mass m carrying charge minus q1 is moving around plus q2 in a circular path. Find its time period. What does time period actually mean? Time period means the time in which it will complete one cycle. It is that time in which it is going to complete one cycle. That is what we call the time period. It is the time in which it will complete one cycle. That's the time period. Now guys, listen to me very carefully. We say, if this charge is revolving around this charge, what is the force acting over here? So first we know electrostatic force is acting. K, Q1, Q2 divided by R square. Yes. Sir, what is the another force that will be acting over here when the charge is revolving in a circular path? Sir, that force is what we call centripetal force. And that force will be equals to m r omega square, or you say mv square by r. Centripetal force is mv square by r. We say v is equal to r omega. It will also come out to be mr omega square. Okay. And these two forces will be equal. So here, when the charge revolves around any other charge, we say in that case, electrostatic force is equal to the centripetal force. Keep this thing directly in your mind. Now, my dear NEET aspirants, you have to find the value of time period. Take it over here. So omega square will come out to be, that is K Q1 Q2 divided by M. R into R will be R cube. Now tell me one thing. So this omega is going to be under root of, this is K Q1 Q2 divided by M R cube. Now what is the value of omega? Omega we can write 2 pi divided by T. Under root of, we say K Q1 Q2 divided by M R cube. Now do the reciprocal. So we can say T divided by 2 pi. Okay. It is going to be under root of K Q1 Q2 divided by, okay, do the reciprocal over here also. This is going to be M R cube upon K Q1 Q2. Now take this 2 pi over here. This is going to be 2 pi under root of mr cube divided by k q1 q2. This is going to be the time period. So when a charge is revolving any other charge, then two forces will act, centripetal force and electrostatic force. Both will be equal. Balance them. Is this clear? Please tell me in the chats. Everybody out there. Is this clear? Tell me. Equilibrium of suspended charges. Equilibrium of suspended charges. Okay, that's great, ladies and gentlemen. Let's move on to the equilibrium of suspended charges. Now take a look. Take a look. Equilibrium of suspended charges actually mean you have got, let's suppose there's a ceiling and there is a thread or there's a rope. With the rope, you are connecting a charge over here or a sphere which has got charge Q. Then you have got another rope and another charge is connected to this rope, which is Q. This is Q and this is Q. Okay. Now tell me. We say, let's suppose this is one rope, this is another rope. Okay. You are attaching a charge positive to this. You are attaching a charge positive to this. So we say these two charges are going to repel each other. We say they will repel. And after certain distance, they will stop. They'll keep themselves like this after some distance. Now, this is what we call the equilibrium position of the two charges. They will remain at rest like this. This is called equilibrium position. The question says, if these two charges are in the equilibrium at distance, let's suppose x. At distance, let's suppose x. Okay. You have to tell me what is going to be this angle with the vertical? What is going to be the tension in the rope? What is going to be the discharge? What is going to be the value of this x? You have to tell me all these values. 4 questions. See, guys. Whenever the question you have something like this, whenever the charge is in equilibrium or any body is in the equilibrium, I told you recently in force and laws of motion. If the charge is in the equilibrium, balance the forces. What are the forces acting? What are the forces acting on this charge? Tell me, guys. In the downward direction, you say m into g. Sir, this plus q is repelling this plus q with electrostatic force. That is equal to k. Q into q is q square. Q1, q2, q square divided by x square. Because distance between them is x. And this is tension T. If this is theta, this is also going to be theta. So this component will be T cos theta and this component is going to be T sin theta. Whenever you see the word equilibrium, you draw all the forces acting on the body, then balance the forces. Now, if the charge is in the equilibrium, we say this force is equal to this force. This T sine theta will be equals to K Q square divided by X square. And this upward force is equal to downward force. T cos theta will be equals to mg. Now divide the two. Divide the two. When you divide the two, we say T and T will cancel. Sin theta by cos theta is tan theta. It will come out to be K Q square divided by this X square, and you have this mg. So this is the value of theta. This is the value of theta. That is KQ square upon X square into mg. KQ square upon X square into mg. Yes, we got the value of theta. Theta is equal to tan inverse of KQ square upon X square into mg. Let's find the value of Q and X. See guys, you got tan theta is equal to KQ square upon X square mg. Let's find the value of Q and X. Listen to me very carefully. Listen to me very carefully. Let's, from this equation, let's find the value of this Q. So take this over here. This is going to be X square mg. Then we say tan theta. So from this side, it is going to be KQ square. Take this K down. So Q square will come out to be, or directly I would say this Q will come out to be under root of, I would say, X square mg tan of theta divided by K. This is the value of Q. And this was asked in JEE 2021. Then, my dear NEET aspirants, from this only, if you have to find the value of X, take this X over here, tan theta over here. So this X square will come out to be KQ square upon, we say, mg, and then we write over here tan theta. And then instead of square, we can put the root over here. It is going to be under root of KQ square upon, we say mg, then we say tan theta, mg tan theta. This is going to be the value of X, and this was also asked in JEE 2021. Tell me, is this clear? I thank you, sir, for your lectures. Help me in J mains. Thank you. Thank you. Is that clear? Tell me. Now, we have to find the tension. We have to find the tension. See, guys, this is the charge Q. What is the force acting in the downward direction? That is mg. What is the force in this direction? KQ square divided by X square. That is electrostatic force. F electrostatic. And what is the force in this direction? Tension. These forces I am creating now. Electrostatic, mg, and tension. Then we resolve tension in two components, but don't resolve it here. Now guys, tell me one thing. If you have two forces, F1 and F2, they are at an angle of 90 degree. What is going to be the resultant? Resultant in that particular case is going to be under root of F1 square, F2 square, because consider this F1, consider this F2. Okay, that is F1 square plus F2 square plus 2 times of F1, F2 cos of 90 theta. Why? Because angle between these two is 90. So this term will become 0. So it is going to be under root of F1 square plus F2 square. That is R. So resultant will be under root of. What is the value of F1 over here? Fe, so electrostatic whole square, plus what is the value of F2 over here? That is mg, its whole square. This resultant. Now guys, if this charge is in the equilibrium, upward force is equal to downward force. Right side force is equal to left side force. This side force is equal to this side force. So this R must be equal to tension because this charge is in the equilibrium. This is the value of tension. This is the value of tension, my dear NEET aspirants. Tell me, NEET aspirants, is this clear? I'll give you the break. Wait. Okay. This is the value of tension. Now, guys, listen carefully. Listen carefully. Listen carefully. Listen carefully. Let's suppose if the mass of the two spheres is not equal. Here. If you consider mass of the two spheres, mass of this sphere is m, mass of this sphere is m, then this angle will be also theta with the vertical, this angle will be also theta with the vertical. Here we considered mass of the two spheres as same. Then this angle will be also same. Similar mass, similar angle. But if I say mass of the two spheres is not identical, this is very important. Mass of this is m1, mass of this is m2. In that particular case, this will create an angle theta 1 with the vertical. This will create an angle theta 2 with the vertical. Theta 1 and theta 2. And guys, what is the value of this tan theta we recently calculated, okay? Tan theta came, sine, cos, we calculated. Tan theta is kq square by x square mg. In this particular case, we say this tan theta 1 will be k q1 q2 by x square m1 into g, because mass of this will be m1 into g. Because if you consider this as theta 1, theta 2, consider this as theta 1. And this is theta 2. Okay. Similarly, tan theta 2 will be k q1 q2 upon x square m2 into g. M2 into g. Tan theta 2. Now, if you divide the two equations, divide 1 and 2, we say k q1 q2 x square g. So this is going to be m2 by m1. Tan theta 1 divided by tan theta 2 is going to be m2 by m1. Now see. Tan theta 1 is inversely proportional to m1. Tan theta 2 is inversely proportional to m2. So can I say from this tan of theta is inversely proportional to mass? Sir, what does that mean? That means the one which has got more mass will be having less angle. If, let's suppose, there is an object which has less mass, it is difficult for that mass to create more angle, to go more high. That's what it says. If m2 is more, theta 2 will be less. Okay. And my dear friends, you clearly see over here, this tan theta, does it depend upon the charge? Theta does not depend upon the charge. Whatever is the charge of the two, theta does not depend on that. Theta only depends upon the mass. Now take a look at the question. If Q1 is greater than Q2, M1 is equal to M2, means you have got two spheres. Okay. So this is Q1, this is Q2. Its mass is M1, this is mass is M2. In this particular case, M1 is equal to M2, Q1 is greater than Q2. It says, then compare theta 1 and theta 2. I can in this particular case say tan theta does not depend upon charge. So can I not say tan of theta 1 will be equals to tan of theta 2 in this particular case? Why? Because mass is same. Let's suppose you have question. If Q1 is greater than Q2, M1 is less than M2. Guys, we say tan of theta is inversely proportional to mass. So if mass is more, theta will be less. Mass of 1 is less than mass of 2. So can I not say mass of 1 is less? So we say tan of theta 1 is greater than tan of theta 2. Yes, sir. Why? Because M1 is less than M2. Guys, tell me in the chats. The one which is lighter will create more angle. Tell me in the chats, is this clear? Tell me in the chats, is this clear? Okay, that's great. That's great. Now, take a look, guys. Two small spheres, each having a charge plus q, are suspended by an insulating threads of length L from a hook. Okay. Take a look, guys. Two small spheres, each having a charge plus q, are suspended. This is a thread. This is a thread. Two small threads, each having a charge plus q and plus q, are suspended. This is plus q. This is plus q. Are suspended by an insulating threads of length L from a hook. This arrangement is taken to a gravity free space. Guys. If this arrangement is taken to a gravity free space, gravity free space means where there is no gravity. If mg is not acting, can I say in this particular case, it will look like this. Guys, because of mg, mg keeps it like this. If mg is neglected, we say electrostatic force which is acting in this direction, it is going to pull it. So this is going to be the electrostatic force. This is going to be the electrostatic force. This is L, this is L. Okay, it will be like this in gravity free space. Then the angle between the two threads is, angle between the two threads is 180 degree. Theta is equal to 180 degree. And tension in the string is, guys, see. Electrostatic force is outward and this tension will be inwards. So here, tension will be equals to electrostatic force because if the charge is at rest. So inward force is equal to outward force. So here, can I say electrostatic force will be K Q1 Q2, that is K Q square divided by, what is the distance between the two? L plus L is 2L. So that is 2L whole square. So that is going to be K Q square divided by 4L square. This is going to be the tension. Oh, tell me, is this clear? Oh, is this clear? If it is taken to a gravity free space, then I would say it'll be like this. Now comes the electric field. Now comes the electric field. Take a look, guys. Take a look, guys. Is it buffering? Is it so? Is it buffering? Okay. Okay. Now, guys, take a look. Please check your internet connection if you feel if it is buffering, because from my end it is complete. It is perfect. It's perfectly fine. Let's suppose, my dear friends, you have got a magnet over here. This is a magnet. Okay. And I'm placing a coin over here. This is a coin. What is going to happen with the coin? This magnet is going to attract it. If I place the coin over here, it is going to attract it. If I place the coin over here, it is going to attract it. If I place the coin over here, it will attract it. If I place the coin over here, it will attract it. If I place the coin here, it will attract it. If I place the coin over here, it will attract it. Now, if I place the coin over here very far, will it attract? No, sir, it will not attract here. So can I not say this magnet is creating some sort of field around it, in which if any piece of iron comes, it is being attracted? This field is what we call magnetic field. So in this magnetic field, this magnet is in this in this region, in this space. This magnet is attracting the piece of iron. This magnet is attracting the piece of iron. Okay. Now, guys, let's suppose if you have a charge Q. If you bring another charge, we say Q naught over here. This charge is going to, let's suppose, minus Q naught over here. This charge is going to attract it, or let's keep it plus Q naught, because we always take this charge positive. It will be repelled. If you keep this Q naught over here, it will be repelled. If you keep Q naught over here, it will be repelled. If you keep Q naught over here, it will be repelled. If you keep Q naught over here, it will be repelled. So can I not say this Q is also creating some sort of field around it, in which if any other charge comes, it experiences force? This field is what we call electric field. This field is what we call electric field. And this field is what we call magnetic field. This field is what we call electric field. So a charge creates electric field around it. A magnet creates magnetic field around it. Okay, this is how we define electric field. Now see, it's a space, a region around a charge, in which if any other charge comes, it experiences force. Like you have this charge over here, you have another charge Q naught. We say this charge is repelling this Q naught in this direction with a force F. So we say this charge is creating a field around it. Now guys see, let's suppose if you have a positive charge, and if you place a charge Q naught over here, we say this positive is going to repel it in this direction. Here it is going to repel in this direction. Here it is going to repel in this direction. So we say, due to the positive charge, electric field is always away from the charge. Away from the charge. Why? Because positive charge is getting repelled. If there is a negative charge, and if you place over here Q naught, we say it will be attracted. Here attracted. Here attracted. So what we can conclude is that due to the negative charge, we say electric field is always towards the charge. Electric field of negative charges towards the charge. Electric field of positive charges away from the charge. Why? Because another test charge is being repelled over here. Because test charge Q naught is being attracted over here. Now, if I say, sir, since you said a charge creates a field around it, a charge creates a field around it. So at r distance, how much is going to be the electric field due to it? How much is going to be the electric field due to it? You simply say electric field due to a charge. Listen to me very carefully. Electric field due to a charge at r distance, it is going to be k q divided by r square. Kq by r square. So means if you have this charge over here, Sir, at r distance, how much is going to be the electric field? Kq by r square. This is the value, this is the magnitude of the electric field at r distance. This is the magnitude of electric field at r distance. Now, electric field is inversely proportional to r square, so graph is going to be rectangular hyperbola. What does that mean? That means if you move away from the charge, electric field is going to decrease. We say if r increases, electric field will decrease. So near to the charge, electric field will be more. Away from the charge, electric field will be less. Tell me, guys, is this clear? Yeah, I'll teach EM waves also. Wait, I'll teach EM waves also. 606, 0606. Okay. Is that clear? Yes. Now, guys, some graph tricks I just want to show you over here. Before that, you need to remember some sign conventions. Take a look, my dear NEET aspirant. If I say, let's suppose this is a positive charge. Due to the positive charge, electric field is always away from the charge. So this electric field is towards right. Towards a right. If the direction of electric field is towards the right, consider it positive. Consider this electric field positive. If the direction of electric field is towards left, I would say towards left. Towards left. Consider this electric field as negative. If the direction of electric field is towards right, it is positive. If the direction of electric field is towards left, it is negative. Okay. Now, guys, and graph between electric field versus R, it is always rectangular hyperbola. Why? Because electric field is inversely proportional to R square. Now take a look, my dear friends, in this particular case. I would want you guys to focus over here. Let's suppose if I say plot the graph for two positive charges. You have plus Q and you have plus Q. Whenever you have to plot the graph for two positive charges, you make this vertical axis and horizontal axis. On the vertical axis, you will be placing electric field. From the lower side, it is minus negative electric field. Because from upper side, it is positive. From lower side, it is negative. And on this, it is going to be distance R. From this side also, this will be electric field positive. This will be electric field negative. And on this distance, it is R. Now, guys, you have to draw the graph. See, I'll tell you how to make the graph. Due to this positive charge, listen to me very carefully, my dear NEET aspirants. We say electric field is away from the charge. Away will be like this. Away will be like this. So instead of making it here, I'll be making it here. Something like this. Due to this positive charge also, electric field will be like this, away from the charge. First, you have to draw the sign conventions. And this is towards right. We'll be considering this electric field as positive. This is towards left. We will be considering this electric field as negative. This is towards right. We will be considering this electric field as positive. This is towards left. We will be considering this electric field as negative. Okay. Now, guys, electric field on the right side of this charge, right side means this portion. Is it positive or negative? It is positive. So graph will be from the upper side, from the positive side, like this. Graph will be always this rectangular hyperbola. Now come on to the left side of this. Is electric field positive or negative? Negative. So graph will be from the negative side, because from the upper side it is positive, from lower side it is negative. Something like this. Something like this. Now, Electric field on the right of this is positive, so graph will be from the upper side. So it will be it will meet over here. So this is what we call neutral point, where net electric field is 0. And on the left side of this, electric field is negative, so graph will be from the negative side. Tell me in the chats, is this clear? Tell me in the chats, is this clear? Let's suppose I'll make the graph between minus q and minus q. This will clear the confusions out. If you have to plot the graph between minus q and minus q, okay, what is the first thing you guys are supposed to do? We say, let's suppose at r distance, this is electric field, okay, this is minus electric field, this is r, and this is over here electric field, this is minus electric field, and this is r. Now guys, you have to draw the graph for two negative charges. First, draw the sign conventions. In case of negative charge, electric field is towards. This is what we call towards. So I'll be making it over here. In case of this negative charge, electric field is towards. Now guys, this electric field is towards left. Consider this electric field negative. This electric field is towards right. Consider this positive. Make sure you draw the sign conventions all the time, because 99% chances are there you will make the incorrect graph without sign conventions. So this electric field is negative. This electric field is going to be positive. Now, on the right side of this charge, is electric field negative or positive? Negative. So graph will be from the lower side. On the right side of this, is electric field positive or negative? Positive. So graph will be like this. On the right side of this, is electric field negative or positive? Negative. So graph will be from the lower side, something like this. They will meet at this point. This is called neutral point, where net electric field is 0. On the left side of this, electric field is positive, so graph will be from this side. I hope this is crystalline clear, and I have made all the graphs over here. Between positive and negative is over here also. This is not the neutral point, okay? Electric field net is not equal to 0 at this point, because it is not touching. Between negative and negative, we have already made. Between plus q and plus 4q. Guys, electric field of 4q will be bigger. That's why neutral point in this case is shifted towards smaller charge. Shifted towards smaller charge. Tell me in the chats, is this clear? Tell me in the chats, is this clear? Tell me, guys. Okay, that's great. Let's talk about this question. Find the net electric field at the origin. See, guys, find the net electric field at the origin. You have to tell me the net electric field at this point due to all these charges. Now, this first charge, this is the origin. This first charge is at 1 meter distance from the origin. Second charge is at the 2 meter distance from the origin. Third is at 4 meter, next 8 meter, next 16 meter, next 32 meters, next 64 meters, and so on. Now, if I say what is going to be the net electric field, I simply see, due to this positive charge, electric field at this point will be kq divided by r square. Because due to a charge, electric field is kq by r square. R is 1, so 1 square is 1 plus electric field due to this will be kq divided by 2 square. 2 square is 4 plus electric field due to this will be kq divided by 4 square is 16 plus kq divided by electric field due to this is 64 and so on. Now in this particular case, my dear friends, when I say net electric field, take this kq common. It will be 1 plus 1 by 4, then plus 1 by 16, then plus 1 by 64, then plus so on. Okay, plus so on. Now, my dear NEET aspirants, what I can write over here, net electric field in this case will be, guys, this is what we call geometric progression, that is GP. Geometric progression, GP. And you have to basically add all of these terms over here. So how do we add all of these terms? These are the infinite terms. We say A upon 1 minus R. This is how do we find the sum of a GP. Sir, A means the first term. First term. This already we have studied in basic maths. Still, I'm telling you again. A means the first term, and first term in this case is 1. And R is what we call the common ratio. Common ratio. And how do we find the common ratio? Guys, common ratio means take any term. Let's suppose I'm taking 1 by 16. Any term, it is of your choice. Divide it with the term which comes before it. What is before 1 by 16? That is 1 by 4. 4 ones are 4 fours are. So common ratio is 1 by 4. Even if you take this 1 by 64, divide by 1 by 16. That is also 1 by 4. Then we say sum will come out to be, instead of this A, we'll be writing 1 upon 1 minus 1 by 4. It will be 1 upon 4 into 1 is 4. 4 minus 1 is 3. 3 by 4. So it will come out to be 4 by 3. So when you say net electric field in this particular case, guys, that is KQ, and instead of all of this, we say this is KQ. Instead of all of this, it will be 4 by 3. So you will be like, instead of K, it will be Q upon 4 pi epsilon naught. Because instead of K, it is 1 by 4 pi epsilon naught. So then it is 4 by 3. 4 and 4 will cancel. It will be Q divided by 3 pi epsilon naught. This is the net electric field. This is the net electric field. Okay. If I say the question is something like this, find the net electric field at origin. But in this case, this charge is positive, next is negative. This is positive, next is negative, and so on. Now, what is going to be the net electric field in this case? Guys, see. Due to first charge, it is KQ divided by 1 square is 1. And due to the next charge, we consider it negative. Minus KQ divided by 2 square is 4. Plus third charge is positive, it is going to be KQ divided by 4 square is 16 minus KQ divided by 8 square is 64 plus so on. Okay, yes. Now guys, what can we say? Take this KQ common. So we can write over here 1 minus 1 by 4 plus 1 by 16 minus 1 by 64 plus so on. Now this is again GP. How do you find the GP in case of a GP series? How do you find sum? That is A upon 1 minus R. A in this case is 1, first term. Common ratio in this case is, take any term, 1 divided by 16, divide it with the term which comes before it, that is minus 1 by 4, because it is negative. 4 ones are 4 fours are, so it is minus 1 by 4. So sum will come out to be 1 upon 1 minus, and instead of R, I can write minus 1 by 4. So sum will be 1 upon 1 plus 1 by 4. Now guys, 1 upon 4 into 1 is 4. 4 plus 1 is 5. 5 by 4. So take it over there. It will be 4 divided by 5. 4 by 5. 4 by 5. Okay. Now, guys, when it comes to the net electric field is going to be KQ. And instead of all of this, what will you write? That is 4 divided by 5. Now, instead of K, will we write 1 by 4 pi epsilon naught? Then we say 4 by 5. This 4 and 4 will cancel. So Q divided by 5 pi epsilon naught is the answer in this case. Is this clear? Oh, I'll give you the break. Wait. This is a big chapter. I need to finish this in 6 hours only. So for that, you will have to, okay, listen to whatever I say. If you want me to finish this chapter in 9 hours, then okay, I'll give you the break. Okay, it is 8 o'clock. Let me give you the break. But time I'm going to take 9 hours. Will that be okay for you? Else I'll finish this in 6 hours only. But I'll give you the break. I'll give you the break in between. No, not break. I'll give you at 8:40. 8 o'clock is right now, 8:40. Yes. Then only, because I know it is possible for me to finish this in 6 hours. Okay. Okay, smash the like button. Mark your attendance. That is mandatory. Okay. Now, guys, take a look. See, I have shown you all the problem patterns of electric field, but one more important thing. Let's suppose if you have a square, if you have a triangle, okay, if you have let's suppose this pentagon, if you have this hexagon, and if I say identical charges are present at every corner, identical charges are present at every corner, and if I say what is the net electric field at the center, what is the net electric field at the center? Previously we were talking about what is the net force. Right now I'm saying what is the net electric field. This is plus Q, 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 this is plus Q. I'm asking you what is the net electric field at the center. We say net electric field in this case is 0. Net electric field in this case is 0. We say net electric field in this case is 0. We say net electric field in this case is 0. Okay, because logic is same. If identical charges are present at every single corner, then whether it is net force or net electric field, both are going to be 0. Okay? Yes. Yes, absolutely clear, sir. Okay, let's suppose I give you the question something like this. This is plus Q, this is plus Q, this is minus Q, this is minus Q. So tell me what is the net electric field at the center. See how do you solve this. Due to this plus Q charge, electric field at the center is, let's suppose, E, away from the charge. Due to positive charge, electric field is away. Due to this negative charge, electric field is towards the charge at the center. Due to this negative charge, electric field is towards the charge at the center. Due to this positive charge, electric field is away from the charge at the center. Now see, this E and E are in the same direction. So E plus E is 2E. This E plus E is 2E. And angle between the two is 90. When you have two equal vectors, angle between the two is 90. In that particular case, what will be the net? That is root 2 of E. Sir, you have shown us similar type of questions and the forces already. Yes. Yes. Okay. Over there, I was asking net force. Right now, I am asking net electric field. Net electric field. Next pattern is, guys. If you have a charge Q, if you have n times of Q, distance between them is R. We say, where is the net electric field? 0. Over there, I was saying, where is the net force? 0 on the third charge. In this case, I am saying, where is the net electric field? 0. Guys, if this is positive, sir, this is positive, we say net electric field is 0. Net electric field is 0 at R distance. Sorry, at X distance. At X distance. Sir, this X will be R upon under root of n plus 1. Sir, we have already studied this. Yes, exactly similar formula. Let's suppose you have over here plus Q and you have over here minus n times of Q, similar charges. Sir, in this particular case, R is the distance between the two. Sir, in this particular case, could you please tell us where is the net electric field? 0. Sir, net electric field is equal to 0 outside. At what distance? X distance. Sir, this X is going to be R upon under root of n minus 1. In case of forces, I was saying net force is equal to 0. Here I am saying net electric field is equal to 0. Please give me the signal in the chats with the fire emojis if this is clear. Everybody guys, tell me quickly in the chats. Is this crystalline clear? Is this crystalline clear? Now take a look. Electric field due to a charged string. Listen to me very carefully. We say, sir, if there is a charge, there is a field due to the charge. Now, if you place that charge, if you distribute that charge onto this pen is also going to create the electric field. If you place that charge on the ring, that ring is also going to create the electric field. Ring. Now, in this particular case, sir, due to this ring, electric field will be created at X distance. Yes. Whenever there is charge, there is electric field. If you place that charge on this ring, it will create electric field. So, electric field due to this ring at X distance, it is going to be, guys, see, that is KQX. K is Coulomb's constant, Q is the charge on this ring, X is the distance at which you have to find the electric field. Then you have to say upon, we say R square plus X square whole raised power 3 by 2. Whole raised power 3 by 2. This is the electric field due to a ring at X distance. At X distance. Because whenever there is charge, it is going to create the electric field. It is going to create the electric field. Okay. Whenever there is charge, it is going to create the electric field. Yes. Now, my dear friends, let's suppose at center, what is the value of x? 0. Because if you come close at the center, we say value of x will be 0. If you move far from the center, value of x is going to increase. So at center, x is going to be 0. If at center x is 0, you put 0 over here, we say electric field will be 0. Yes, sir. Then we say case 1. Case 1. Very close to the ring. Very close to the ring. Very close to the ring means if this is the ring, you have to find the electric field. Listen to me very carefully, boys and girls. If this is the ring, okay, its radius is, let's suppose, r. You have to find electric field just outside the center. Just outside the center. So here we say x is much, much less than r. It is not exactly at the center, just outside the center. So x is much, much less than r. So in that case, electric field will be, that is kqx upon, we say r square plus x square. Guys, see, if x is a small quantity as compared to r, its square will be more small, because if there is a quantity which is small, if you do it square, it will become more small. And a very small quantity is added to a very large quantity, it will not, will it create any difference? No. Like if I say adding a bucket of water to the ocean, adding a bucket of water to the ocean, will it create any difference? No, sir. Why? Ocean has got billions of liters of water. Adding a bucket will not create any difference. Same is the case over here. You can neglect x. So you can write over here directly r square whole raised power 3 by 2. 2 and 2 will cancel. So electric field will come out to be kqx divided by rq. This is the electric field. This is the electric field due to a ring at x distance. This is the electric field due to a ring at x distance. Then we say case 2. Case 2. Very far from the ring. Far from the ring. Very far from the ring. So my dear NEET aspirants, if this is a ring, okay, if this is a ring, so this is r and this is x. Can I say in this particular case, r is much, much less than x, very far from the ring. Ring is placed very far. So now in this particular case, what is going to be the electric field? kqx upon, we say, if r is very small, x is very large, adding a very small quantity to a very large quantity will not create any difference. You can neglect this r. So you can write over here x square whole raised power 3 by 2. 2 and 2 will cancel. So it is kqx divided by, we say x cube. Now this x and cube will cancel, so it square remains. So kq divided by x square. This is electric field very far. Now see, electric field very close is directly proportional to x. Electric field very far is inversely proportional to x square. So when you are close to the ring, electric field is directly proportional to the x. When you are far from the ring, electric field is inversely proportional to the x. So my dear NEET aspirants, if somebody says, I want to make the graph between, we say electric field versus x. Now guys, at center, value of x is 0. At center, value of x is 0. So electric field is also 0. So graph will start from the origin. And then we say electric field is directly proportional to x. So when the value of x is small, here small, here value of x is large, electric field is directly proportional to x. E is directly proportional to x. And when you go very large, very far, electric field is inversely proportional to x. So you can join the two, something like that. So electric field is inversely proportional to x square, very far. So the graph is going to be something like this, my dear NEET aspirants. See, this is electric field versus x. So we say very close to the ring, it is like this. Very close to the ring, electric field is going to be like this. Very far from the ring, So this is very close. Electric field is directly proportional to x when x is much, much less than r. So this is very far. Electric field is inversely proportional to x square. Okay. And from this side, guys, this side, we say it will create, a ring is going to create the electric field from both the sides. A ring is going to create the electric field from both the sides. Okay. So if this is a ring, it will create electric field from the right side also, from the left side also. This is the electric field from right side, from left side. Electric field on the right we take positive. Electric field towards left we take negative. That's why graph is from the lower side. Oh, is this clear? Oh, tell me in the chats. Is this clear with the fire emojis? Everybody out there? Okay. And one more important thing. Sir, at this point, electric field is maximum. Yes. So from the another side of the ring, electric field is maximum at this point. So at what distance electric field is maximum? We say electric field is maximum at x is equal to plus minus r divided by root. Plus minus r by root. On the right side, electric field is maximum at r by root 2. On the left side, electric field is maximum at r by root minus r by root. I hope this is crystal and clear to each and every single student. Yes, the graph is also clear. Now guys, take a look. One more important thing I just want to clarify over here. Okay. See guys, take a look. Take a look. Take a look. Let's suppose we have a rod over here. Let's suppose we have a sheet over here. Okay. Let's suppose we have a volume over here. There's a football or something like that. There's a sphere over here. Okay. Now I'm asking you the simple thing over here. Let's suppose charge is present on this rod and that is a positive charge. This is the positive charge present on the rod. And how much Q? Length of the rod is L. On L length, Q charge is present. On L length, Q charge is present. On the entire length, Q charge is present. If I say what is the charge on the unit length? Charge on the unit length. So charge on the unit length is going to be total charge divided by total length. That is what we call lambda. Lambda is basically charge per unit length. Lambda helps us to find the charge on the unit length. Okay. 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 Yes. So this is basically the charge on the unit length, that is lambda. Similarly, if you have a sheet, charge is present distributed on the sheet. Okay. And area of the sheet is A, charge is Q. If I say what is the charge present on the unit area? Charge on unit area. Sir, how do we find the charge on unit area? You say, sir, total charge divided by total area. That is going to be sigma. So sigma helps us to find the charge present on the unit area. Lambda helps us to present the charge on unit length. This is also what we call the linear charge density. Linear charge density. And this is what we call surface charge density. Then you have this. Let's suppose charge is present in the volume V. Charge is present in its volumes. Q charge is present in volume V. Let's suppose you consider over here volume, I would say dV, or we say unit volume. In this unit volume, how much is the charge present? That is going to be rho. That is total charge divided by total volume. This is charge present in the unit volume. This is also what we call the volume charge density. Volume charge density. I hope you got the feel of these. Okay. So whenever you have a rod ring, you take lambda, charge per unit length. Whenever you have an area, you take sigma. Okay. 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 If the charge is not uniform, in that case, you can simply say rho is equal to dq divided by dv. Okay. So if the charge is not uniform, in that case, you can simply say dq divided by dA. Here you can say lambda is equal to, that is dq divided by dl. Okay. So basically, if the charge present on the rod is uniform at every single point, similar amount of charge is present, you can say total by total. If the charge is not uniform, you can say dq by dl. Here, if the charge is not uniform, you can say dq by dA. If the charge is not uniform, you can say dq by dv, because in the small volume, charge will be constant. Is that clear? Is that clear? Tell me. Now, guys, let's suppose you have a ring over here. This is a complete ring. If I want you guys to distribute this ring in two parts, you'll break it. This is what we call semicircular ring. This is what we call semicircular ring. A complete ring is divided into two rings, two semicircular rings. A complete ring is divided into two semicircular rings. If I say you divide this into four parts, this is what we call chord. If I say you take some portion of the ring from here to here, or you say from here to here, this some portion of the ring is what we call arc, ARC. Or this is also what we call segment of ring. Segment of ring means some portion of the ring. Segment of ring means some portion of the ring. Some portion of the ring. Let's suppose you are taking some portion of the ring, segment of ring, like this is a complete ring. Okay. You are taking from here to here. This is radius r, this radius r. Angle between the two is theta. So you are taking some portion of the ring. Charge present on this linear charge density is lambda. Charge present on the unit length. Okay. Now guys, this is the radius r. This is radius r. Angle between the two radius over here is theta. Now if somebody says, what is the electric field due to the segment of ring at this point? Since this is a positive charge, it will be away from the charge, electric field. So electric field is going to be 2k lambda by r. K is Coulomb's constant, lambda is charge per unit length, r is radius, sine of theta by 2. Theta is the angle between this radius and this radius. Okay. Yes. Let's suppose if you have a semicircular ring. Now this is R, this is R. Now angle between the two radius is theta. Theta here is 180. So we say electric field is going to be 2k lambda by R, sine of theta by 2, sine of 180 by 2. Because this is what you will be considering as general formula. This is what we will be considering as general formula. So this is electric field. Electric field is going to be 2k lambda by R. Sine of theta by 2 is sine of 90. Sine 90 is 1. Sine 90 is 1. So electric field will be 2k lambda divided by R. This is the electric field due to a semicircular ring at this point. And since this is positive, electric field will be away from the charge. Electric field will be away from the charge. Since this is positive, electric field is going to be away from the charge. Okay. Okay. Yes. Let's suppose, my dear NEET aspirants, you have got a chord over here. So this is radius R. This is radius R. Chord means one complete ring has 4 chords. In this particular case, what is the angle between the two radius? That is 90 degrees. So if I say what is the electric field, it will be like 2k lambda by R sine of theta by 2, that is 90 by 2. 90 by 2 is 45. Sine 45 is 1 by root 2. Electric field will be 2k lambda by R sine 45, that is 1 divided by root 2. Now what I would want you guys to do is multiply with root 2 and divide with root 2. Now see. Root 2 into root 2 is 2, because that is root 2 whole square. Root 2 into root 2 is 2. That 2 will be cancelled with this 2. Now what remains? Root 2 k lambda by R. Root 2 k lambda divided by R. This is the electric field due to a chord at this particular point. And if the charge is positive, electric field is going to be away from the chord. If the charge is positive, electric field is going to be away from the chord. Is that clear? Okay. Let's suppose you have this question. Find net electric field. Guys, you have a question something like this. Half of the chord have got, half of the semicircle have got positive charge, half of the semicircle have got negative charge. And clearly, if you have a question something like this, I would suggest you guys to divide this in 2 chords. Because one chord has got positive, one has got negative. Now see, electric field due to this positively charged chord, it is away from the chord because it is positive, and it will be root 2 k lambda by R. Why, sir? Because if the radius is R. Why? Because it is a chord. Due to chord, it is root 2 k lambda by R. Due to this negatively charged chord, electric field will be also root 2 k lambda by R. And it will be towards the chord. And my dear NEET aspirants, listen to me very carefully. If this is a circle, in case of a circle, we always say this angle is 90, this is 90, this is 90, this is 90, total is 360. So how much is going to be this angle? 90, because this is 45, this is 45. Now guys, you have 2 vectors. One vector is root 2 k lambda by R in this direction. Another vector is root 2 k lambda by R. Now, could you please tell me angle between the two vectors is 90? If you have two vectors, angle between the two is 90. What is going to be the net electric field? Net electric field is going to be, if this is x, resultant will be root 2x. If this is f, resultant is root 2f. If this is root 2k lambda by r, root 2k lambda by r, resultant will be root 2 of root 2k lambda by r. Root 2 into root 2 is 2. That is 2k lambda by r. 2k lambda by r. This is the net electric field in this case. Let's suppose you have a question something like this. Find the net electric field at the center. Guys, see, the question is like this. This is positive, 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 positive. Then you have negative, 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 positive, 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 positive. Okay, something like this. Okay, cool, cool, cool. Now, guys, clearly this is a complete ring. Half of the ring has positive, half of the ring has negative. What I can suggest you guys to break this into two semicircular rings. Okay. Due to upper semicircular ring, electric field will be away from the ring. 2k lambda by r. Why? Because due to a semicircular ring, electric field is 2k lambda by r. Due to this lower semicircular ring, electric field is towards, that is also 2k lambda by r. Because electric field due to a semicircular ring is 2k lambda by r. Now depends upon if the charge is positive or negative. Now these two are in the same direction. We can say net electric field is 4k lambda by r. 4k lambda by r. Let's suppose you have this. And in this case, I would suggest you guys to break this into four parts. Break this into four parts. Okay, break this into four parts. This one and this one. Now guys, clearly you can see due to this positively charged cord, electric field is away. And how much is that? Root 2k lambda by r. Root 2k lambda by r. Due to this positively charged cord, electric field is away. How much? Root 2k lambda by r. Due to this negatively charged cord, electric field is towards. How much? Root 2k lambda by r. Due to this negatively charged cord, electric field is root 2k lambda by r. This will cancel this. This will cancel this. Net electric field at the center is 0. Net electric field is 0. Is this clear? Oh? Tell me in the chats. Is this clear? Is this clear? Is this clear? Is this clear? Yes. Find the electric field at the center. Wait, guys. You have to tell me the electric field at the center. You have to tell me electric field at the center. See. In this case, you break this in four chords. You break this in four chords. Okay. Now, due to this chord, electric field is away. How much? Root 2k lambda by r. Root 2k lambda by r. Due to this chord, electric field is towards. How much? Root 2k lambda by r. Due to this chord, electric field is root 2k lambda by r. Due to this chord, electric field is root 2k lambda by r. Now, due to this chord, electric field is towards root 2k lambda by r. Due to this chord, electric field is towards root 2k lambda by r. This will cancel with this, but these two will add up. These two will add up. So this is root 2k lambda by r plus root 2k lambda by r. So net electric field will be root 2k lambda by r plus root 2k lambda by r. So 1 plus 1 is 2. So 2 times of root 2k lambda by r. This is the net answer. I hope this is crystalline clear. I hope this is crystalline clear. I hope this is crystalline clear. Okay. Let's suppose you have a question something like this. You have a question something like this. This angle is 120 degrees. This is lambda. Find the net electric field at center. Find the net electric field at center. Guys, what will you consider this? Semicircle, complete circle, chord, or an arc? Will we consider this an arc? Consider an arc. And what is the electric field due to an arc? 2k lambda by r. Then we say sine of theta by 2. Because this is not a semicircle, this is not a chord, this is an arc. And in this case, theta is given as 120. So this is going to be 2k lambda by r. I would say sine of 120 by 2. 120 by 2 is 60. Sine 60 is root 3 by 2. So this is going to be 2k lambda by r. Then it will be a root 3 divided by 2. 2 and 2 will cancel. So this will come out to be root 3k lambda divided by r. And direction of the electric field will be away. Why? Because the charge is positive. Charge is positive. Yes, sir. Yes, sir. One more question, guys. This question, find the horizontal and vertical components of the magnetic field, of the electric field. Horizontal and vertical component. This I'll give you as homework. This I'll give you as homework. This is a very good question. Okay. This I'll give you as homework. Take a look. Take a look, guys. Finite charge. Okay. Now, my dear NEET aspirants, you have a question something like this. Let's suppose you have a rod. Its charge is Q. Okay. And charge density in this particular case is given as lambda. Charge density in this case is lambda. If I say, sir, what is the electric field due to this finite rod at r distance? Now, you take this point, you join it with one end, you join this with another end. So this angle is theta 1, this angle is theta 2, and this is r. You have to tell me in this particular case, what is the electric field at r distance? Electric field will be k lambda by r, sine of theta 1 plus sine of theta 2 into I cap plus cos of theta 1 minus cos of theta 2 into j cap. This is what we call electric field due to a finite charged rod at any point. And by the way, this is not in your syllabus. In your syllabus, what is there? That is electric field due to an infinitely long rod. Infinitely long rod. There is a charged rod which is going till infinity. This is another charged rod which is going till infinity. Electric field due to this, you can consider it. It is going till infinity. Electric field due to this at r distance will be 2k lambda by r. Sir, it was due to a semicircular ring. Yes, it is due to an infinitely long rod also. 2k lambda by r. And electric field due to a semi-infinitely long rod. Sir, what is the difference between infinitely long rod and semi-infinitely long rod? Sir, semi-infinitely long rod means which is going till infinity from one end only. Another end is finite. So what is the electric field due to the semi-infinitely long rod? Guys, see. So it is a root 2k lambda by r. That's it. You have to remember this much only. Due to an infinitely long rod, it is 2k lambda by r. Due to a semi-infinitely long rod, it is root 2k lambda by r. That is more than sufficient. That's it. Here I have basically derived it completely. You can check it out also. But you directly remember root 2k lambda by r. Let's take a look at the question which was asked in NEET 2019. NEET 2019. Let's take a look at the question. The question is, you have got an infinitely long rod, lambda, you have got another infinitely long rod, that is lambda. You have to tell me electric field at the midway, and this is negatively charged rod, minus lambda. You have to tell me electric field at the midway. See guys. Due to this positively charged long rod, okay, electric field at this point will be away from the rod. 2k lambda by r. Because due to an infinitely long rod, it is 2k lambda by r. Now, due to this negatively charged rod, it will be 2k lambda by r. 2k lambda by r. Okay. So what is going to be the net electric field? Guys, due to the negatively charged rod, electric field is towards. Due to the positively charged rod, electric field is away. So we say it is 2k lambda by r plus 2k lambda by r. 2 plus 2 is 4k lambda by r. This is the answer to the question. This is the answer to the question. Okay. This is the answer to the question. Now, guys, see. There is a question over here. See. Let me show you on this slide. There is an infinitely long rod. Okay. Infinitely long rod. And there is a charge placed over here. There is a charge, minus q charge placed over here. If I give some velocity to this charge, it will start revolving around this, and this distance is given as r. It will start revolving around this. And this is charge on this is plus lambda. This is positive. What should be the value of this velocity so that it can revolve around the rod? What should be the value of this velocity so that it will revolve around this infinitely long rod? See guys. When it comes to the question of circular motion, I told you only one thing. Balance the electrostatic force with the centripetal force. Balance the electrostatic force with the centripetal force. We say, guys, see. This is revolving around this. Okay. So we say in this particular case, centripetal force will be acting. That will be equals to electrostatic. That will be equals to that. That's it. Whenever you have a question something like this in which you have circular motion, there is this two charges, balance the two. Now, what is centripetal force? mv square by r. Because centripetal force on the particle is mv square by r. That's the mass of this is m. And electrostatic force. Guys, see. Always remember, this I'll tell you after some time. If you have an electric field, and if there is a charge present in the electric field, we say force acts on this charge, that is equal to Q times of E. If there is an electric field, in that electric field, if you place any other charge, on that any other charge, force acts, that is what we call Q times of E. This is the force acting on the charge. Now here, due to this infinitely long rod, electric field is present over here. 2k lambda by r. And in that electric field, you see this negative charge is present. So we say force acts on this, that is Q times of E. Now what will you say? Sir, mv square by r, it will be equals to Q. What is the electric field due to infinitely long rod at r distance? 2k lambda by r and r will cancel. You have to find the value of v. V square will be 2k q lambda divided by this m. So v will be equals to under root of 2k q lambda divided by m. This is the velocity with which it will revolve. Please tell me in the chats if this question is clear. Everybody out there. Tell me. Tell me. Yes, it's 8:40. Just a second. It's 8:43. Just a second. Just a second. Just a second. This will give you the break. Okay. 8:44. Let's take the break. Break till 9:40. This is the long break. Get done with your dinner. After the dinner, we'll take just 1 hour in completing the entire session. So, guys, am I audible? Tell me quickly in the chats. Okay, so ladies and gentlemen, boys and girls, let's move on to the topic that is what we call electric flux. What does electric flux actually mean? Listen carefully, listen very carefully. See, guys, let's suppose we have, we have, let's suppose, let's suppose we have a surface over here, sheet over here. Okay, this is a sheet, and this is one more sheet. Okay, and these are the electric field lines which are coming something like this. Yes, these are the electric field lines. Okay, these are the electric field lines. Okay, now my dear friends, in this particular case, let's suppose you are taking two sheets over here and electric field is crossing these two sheets. Let's suppose you have kept a charge over here, you have placed a charge over here. Due to that charge, we say electric field lines are coming out. It is crossing the surface 1 and it is crossing the surface 2. Now, my dear friends, in this particular case, if I ask you, how many number of field lines are crossing surface 1? 1, 2, 3, 4, 5, 6. How many number of field lines are crossing surface 2? 1, 2, 3, 4. Only 4. So what I can say, flux through surface 1 is 4. Sorry, is 6. And flux through surface 2 is 4. So electric flux is nothing but, we represent this electric flux with phi. Electric flux is nothing but the number of field lines crossing the surface perpendicularly. If more number of field lines are crossing the surface, more it's going to be the flux. Like here, 6 number of field lines are crossing, so 6. 6 will be the flux. And my dear NEET aspirants, clearly I can say in this particular case, this flux is directly proportional to electric field. More is the electric field, more field lines will be there, more is going to be the flux. And this flux is directly proportional to area. You see, area of first surface is greater than area of second surface. So flux through first surface is greater than flux through second surface. So if you combine the two, you say flux is equal to E dot A. E dot A. So this is what we call electric flux. So simply, if you have to define electric flux, it is simply the number of electric field lines crossing the surface perpendicularly. How many number of field lines are crossing the surface? That is what we call electric flux. That is how we define electric flux. Okay. Yes. E vector dot area vector. Now, my dear NEET aspirants, listen to me very carefully. Let's suppose, and one more important thing, E dot A, we can write it EA cos theta also. Because E vector dot A vector is EA cos theta. See, guys. Sir, electric flux is directly proportional to field. Understood. Electric flux is directly proportional to area. Understood. Sir, what is this cos theta? See, guys. Let's suppose you have a surface over here. Let's suppose you have a surface over here. This is the surface. Okay. And electric field crossing the surface is making an angle of theta with the horizontal. This is the electric field. Now, my dear NEET aspirants, In this particular case, if I say electric field, this component is E cos theta, this component of electric field is E sin theta. If electric field is, it is like this. If electric field is not perpendicular to the surface, if electric field is like this, it will have two components, E cos and E sin. Now, my dear friends, in this particular case, if I ask you which of the two components is crossing the surface perpendicularly, you say, sir, cos. So we say this E cos is going to create flux. This is going to create flux. Create flux. Sir, this is not crossing, so this will not create flux. So if I say what is the flux over here, you'll be simply saying, sir, that is E cos theta into area is going to be A. So that is why we say it is EA cos theta. Because you have to take that component which is crossing the surface perpendicularly, which is crossing the surface perpendicularly. Yes. Like, if I say what is the flux in this particular case? What is the flux in this? This is the electric field. And this electric field is making an angle theta with the horizontal. Now guys, if this is electric field E, this component of electric field, it is simply going to be E cos theta. Okay. And this vertical component is going to be E sin theta. This is the area A. It is like this. It is like this. This E cos theta, E sin theta. Can I say in this particular case here, E sin theta is crossing the surface. So the one which crosses the surface will create flux. So in this particular case, you simply say flux is, that is E sin of theta. E sin of theta into area is A. So here flux is going to be EA sin theta. So it is not always cos component. It is actually that component. It is actually that component which crosses the surface perpendicularly. Here E sin theta is crossing. That's why in flux I am taking E sin theta. I am taking E sin theta. Like, let's suppose you have a question over here. What is the flux passing through the surface? Flux will be zero. Why? Because no field line is crossing the surface. It is just touching the surface. These field lines are just touching the surface. That's why flux is not zero. That's why flux is zero. And this is the question from AIPMT 2015. Sir, what is the outward flux through the cylinder? Guys, see. If I say the field lines are going inside this surface, this is area. And always remember, let's suppose if we have a sheet over here. Let's suppose if we have a sheet over here. This is the sheet. Sir, what is the direction of area of sheet? Direction of area is always perpendicular to this surface. Sir, is area vector quantity or scalar quantity? It is a vector quantity. So, direction of this vector is always perpendicular to the surface, either upward or you can say downward here. Direction of the area of the board is always perpendicular to the surface. Yes. Now see guys. Here, this electric field is going in. And area of this portion is perpendicular to the surface, that is out. If I say here, flux inward, this is what we call inward flux. When the field lines are going in, that's what we call inward flux. And that is going to be electric field is E, area is A, and then we say cos of theta. Theta is the angle between electric field and area, that is 180. So that is going to be minus E into A. And area will be, area of this disk is pi r square. So that is E into pi r square. This is inward flux. And my dear NEET aspirants, if I say what is the outward flux? Outward flux means when the field lines are coming out. And area of this is also perpendicular. It is a cylinder actually. See guys, when field line is going in, area is perpendicular to the surface outward. When field line is coming out, area is also perpendicular to the surface in that particular case. So here, angle between electric field and area is 0. So you say flux is electric field into area, then you say cos of 0. Cos 0 is 1. So flux outward in this particular case is going to be EA. Okay, and you can say it E into pi r square. Now, my dear NEET aspirants, in this particular case, if I say what is going to be the net flux is going to be, that is inward flux plus, I would say, outward flux. So that is minus E into pi r square, then plus E into pi r square. This and this will cancel. Net flux will be 0. Net flux will be 0. As simple as that. As simple as that. Okay. So my dear NEET aspirants, from now onwards, you'll be remembering that. See, if the number of field lines going inside a closed surface is equal to the number of field lines coming out of the closed surface, then net flux in that case will be 0. Net flux in that case will be 0. If the number of field lines going inside a closed surface is equal to the number of field lines coming out of the closed surface, net flux will be 0. Please tell me in the chats if this is clear. Please tell me in the chats if this is clear. Everybody, guys, quick. Quick. Here, flux inward is E into A. Let's suppose area of this is A. E into A. This is the area. Electric field, angle between electric field and area is 180. So minus EA. Outward flux is plus EA. Okay. So net flux in this case is 0. Net flux in this case is 0. Gauss law. See what does the Gauss law say? See what does the Gauss law say? Let's suppose you have a closed surface. This is a closed surface. Okay. And inside this closed surface, you have got a charge. Closed surface means spherical surface, cube. Now we know that due to this charge, electric field lines are coming out. Due to this charge, electric field lines are coming out. Okay, these are the electric field lines coming out of the charge. Yes, sir. Due to the charge, electric field lines are coming out. So it will create the flux. Because whenever the electric field lines cross the surface, it creates flux. So through this closed surface, it will create flux. Now, if I say how much is the flux created through this closed surface? So according to Gauss, flux through the closed surface is whatever is the charge inside divided with the epsilon naught. That's it. This is Gauss law. What does Gauss law say? If you have a charge inside a closed surface, we say electric field will come out of that closed surface. Okay. And that will cross the surface. So flux is created. So that flux through the closed surface is Q inside by epsilon naught. Q inside by epsilon naught. So means if I say you have a closed surface over here, you place 10Q inside. What is the flux through this closed surface? So that is 10Q divided by epsilon naught. As simple as that. This is according to the Gauss law. Like here, the charge is present inside the cylinder. How much is the flux through the closed surface? Q by epsilon naught. The charge is present inside the cube. How much is flux through the surface? Q by epsilon naught. Q by epsilon naught. Q by epsilon naught. Yes. Now find the flux through the cylinder. Guys. You have got a cylinder something like this. This is the charge. Is this charge inside? No, it is not an enclosed charge. Flux through a closed surface is always enclosed charge divided by epsilon naught. But this is not an enclosed charge. So what we do in this particular case is charge is present at the mouth. It is something like this. Charge is present at the mouth of the cylinder. What we do here is we attach one more imaginary cylinder to this. Let's assume we are attaching one more cylinder to this. Now, don't you think that with the help of these two cylinders, this charge became the enclosed charge? Yes. So with the help of these two cylinders, it makes the closed surface. So you can say flux through the closed surface, that will be equals to flux through two cylinders. Sir, for this charge, closed surface means two cylinders, not just one. It is equal to Q divided by epsilon naught. This is flux through two cylinders. If I say what is the flux through one cylinder, that will be 1/2 of Q by epsilon naught. Because this is flux through two. Half of flux through one will be half of this. Okay, that is Q divided by epsilon. Q divided by epsilon. Let's suppose you have this. See guys, if you have a cube, charge is present at this corner. Now guys, if the charge is present at this corner, how many more cubes we need to connect over here so that this is this the enclosed charge? Guys, see. If I say charge is present inside the cube, how much will be the flux? Q by epsilon naught. But is this charge inside the cube? No, it is present at this edge, at this edge. Okay, at this edge. How many more cubes I need to connect so that it will become enclosed? 1, 2, 3 more cubes. We say add 3 more cubes to make it an enclosed charge. Okay. So can I say flux through total 3 more cubes plus this cube, flux through 4 cubes will be equals to flux through closed surface? Because due to 4 cubes, this will become now an enclosed charge. So this will be equals to Q divided by epsilon naught. So if I say flux through 1 cube, it is going to be Q divided by, we say 4 epsilon naught. Okay, so even I can make you understand it like this also. See guys, in this particular case, let's suppose you have a charge over here. You want to make it enclosed charge. Let me show you. How many more cubes I need to attach over here so that it becomes an enclosed charge? First one from this side. Second one from this side. Third one from this side. Now see, this charge is now an enclosed charge. So I have attached 3 more cubes and this charge became enclosed. So total of 4 cubes make the closed surface over here. If the charge is present at the corner, now directly remember, in this particular case, we say add. Guys, when the charge is present at the corner, you have to add 7 more cubes. 7 more cubes to make it an enclosed charge. So total of 8. 7 plus this one is 8. So flux through 8 cubes will be equals to flux through closed surface. Flux through 8 cubes will be equals to the flux through the closed surface. And that will be Q divided by epsilon naught. This flux through 8 cubes, what is going to be the flux through 1 cube? That is going to be Q divided by 8 epsilon. Guys, tell me in the chats if this is clear. Tell me in the chats if this is clear. Sir, how 8 charges came? 8 cubes came. If the charge is present at the corner, if the charge is present at the corner, see, you need to make this an enclosed charge. How many more cubes you need to attach so that it becomes enclosed? One is from this side, another is from this side, another is from front side. Now, one is at the top, one, two, this one, three, this one, four. Total of 7 cubes I have added over here. Okay. Plus the one which was already there. So total of 8 cubes. Oh, understood. Tell me the chats now. Flux passing through R. R is this surface. Flux passing through, don't say R, flux passing through curved surface. Curved surface is phi naught. Find flux passing through one plane surface. See, when it comes to sir, in denominator you mentioned 8. Yes, I am supposed to mention 8 because it is total of 8 cubes. 7 I am adding. Add 7 more cubes. 1 is already there. 7 plus 1 is 8. That's why Q by 8 epsilon naught. Total are 8. Flux due to 8 cubes means flux due to closed surface. When it comes to this closed surface, cylindrical surface, it has got 3 surfaces: plane, plane, and curved. Plane, plane, and curved. Now, my dear friends, if I say flux through the closed surface, here closed surface, this closed surface is made of 3 surfaces. That means one curved surface, one CS, plus 2 plane surfaces. So if I say flux through this closed surface, that means flux through one curved plus flux through 2 plane. It is one and the same thing. Now flux through closed surface will be Q divided by epsilon naught is equal to flux through curved surface, that is given as phi naught. Flux passing through the curved surface is phi naught. Plus I would say flux through 2 plane surfaces. Take it over here. So flux through 2 plane surfaces will come out to be Q divided by epsilon naught minus phi naught. So flux through one plane surface, it is going to be through 2, it is this much. Through 1, it is going to be 1/2 of Q divided by epsilon naught minus phi naught. This is going to be the flux through one plane surface. So if flux through 2 is this much, flux through 1 will be half of this much. I hope this is clear. This I am giving you as homework. It is on the same concept. Okay. Find the flux passing through the curved part. Okay. Don't keep it open. Keep it closed. Keep it closed. It's a hemispherical bowl. Hemispherical bowl. Hemispherical bowl. Now see, find the flux through the sphere. Take a look, guys. When it comes to the, this is basically a sphere, and a rod is passing through the sphere, something like this, which has charge density lambda. When it comes to flux through closed surface, that is charge inside divided by epsilon naught. Now the question in this particular case is charge is not given, charge inside is not given. You have to find out how much is the charge inside. See, how do we find the charge inside? Guys, see. We say as lambda, this lambda is given, lambda is equal to charge divided by length. Now if you want to find the charge inside, you have to say lambda into length inside. How much is the length of the rod inside? Multiplied by lambda, that will give you the charge inside. Now you have to find this length inside, this length inside. Now guys, see, this is r by 2. This is given as radius r. This you consider as x. Now from this triangle, listen. Can I not say from the triangle, this hypotenuse square from the triangle, can I not say this hypotenuse square will be equals to base square, that is r by 2 whole square, that is r square by 4 plus perpendicular square. Hypotenuse square is equal to base square plus perpendicular square. Now take it over here. R square minus r square by 2. That is 4r square. Guys, this is take it over here. So this is r square minus r square divided by 4 is equal to x square. So can I say this is 4r square minus r square? That is 3r square divided by 4 is equal to x square. Now take this over here. X will come out to be, that is root 3 r divided by 2. Because if you put the root from this side, it will be root 3 r square and root will cancel by 2. Now this is x. How much is going to be this x? This distance x. So that is 2x. X plus x is 2x. So what I can write in this particular case, that is 2x is going to be root 3r divided by 2 into this 2. 2 and 2 will cancel. Root 3r. This is the length inside. This is the length of the rod inside. Now put it over here. So what is going to be charge inside? That is lambda into root 3r. So can I say what is the flux passing through this closed surface? That is q inside. Instead of q inside, that is root 3 lambda r divided by epsilon naught. This is the answer to the question. Tell me, is this clear? Is this clear? Charge distribution is same over here. What is the flux passing through ABCD? Guys, there is a charge present here at, let's suppose, A distance. Charge, not A. Charge from this side, charge is present at L by 2 distance. This charge is present at L by 2 distance from this side. This charge is also present at L by 2. In this particular case, we say electric field coming out of this charge crosses this surface. So the number of electric field lines going out is equal to the number of electric field lines going in. So we say flux net through ABCD phase, it is 0. Net flux through ABCD phase will be 0. Because due to this charge, field lines are going out. Due to this charge, field lines are going in. So net flux through ABCD will be 0. I hope this is also clear. I hope this is also clear. Now, guys, in this particular case, we will be talking about electric field due to a hollow sphere. Hollow sphere, or we say metal sphere, or we say conducting sphere. Conducting sphere. Let's talk about electric field due to a hollow sphere, or we say metal sphere, or we say conducting sphere. Okay. Electric field due to a hollow sphere, or we say metal sphere, or we say conducting sphere. My dear friends, if you have a hollow sphere, its charge is Q, radius is R. Let's find electric field due to this outside first. Electric field outside at small r distance. It is simply going to be kq divided by small r square. This is electric field outside the hollow sphere. If I say on the surface, on the surface, on the surface, on the surface, I can simply say value of small r is capital R. On the surface, value of small r, because if you move towards the surface, so we say whatever is the value of small r, same as capital R. So we can say electric field on the surface, it is going to be kq divided by capital R square. Instead of small r, I'm putting capital R. Guys, when we talk about the hollow sphere or conducting sphere, charge is present on the surface only. Charge inside the hollow sphere is zero. If there is no charge inside, guys, if there is no charge inside, we say electric field inside the hollow sphere is zero. Done and dusted, sir. Electric field inside the hollow sphere is zero. Now if I plot the graph, between electric field versus R, electric field versus R, here R is equal to 0. Now electric field, we say from center to surface, here at surface R is equal to capital R, we say electric field inside is equal to 0. And then outside it is inversely proportional to small r square. Clearly you can see electric field outside is inversely proportional to small r square. Okay. Okay, so it will be rectangular hyperbola. Till surface, it is 0. It is very important. It has been asked many times in the NEET. Next, if we talk about solid sphere, now my dear friends, if I say what is the electric field due to a solid sphere outside, guys, sir, this formula is similar to electric field due to a point charge. Yes. Why? Because if let's suppose I give you a hollow sphere, it's a big balloon, let's suppose. Now your friend is looking at this balloon from a very large distance. Your friend is looking at this balloon from a very large distance. Now, to your friend, it feels like he's looking at a point. Or if I give a balloon to your friend, you are looking at that balloon from a very large distance, 2 kilometers, 3 kilometers away. So it feels like it is a point at a very large distance. So it appears to be a point. So that's why electric field outside at very large distance is like a point charge, kq by r square. Okay. Now, even if it is a hollow sphere or solid sphere at very large distance, both we consider as point charges. So electric field at outside, it is going to be kq divided by small r square. Kq divided by small r square. Okay. And we say on the surface, value of small r is equal to capital R. So electric field on the surface is going to be kq divided by capital R square. Kq by capital R square. And when I say inside, guys, inside, this is a solid sphere. Solid sphere means non-conducting sphere. In case of solid sphere, electric field charge is present inside. Inside charge is not 0. So electric field inside is going to be simply kq and small r. Sir, small r is variable for outside point. For outside point, small r is greater than this capital R, where capital R is radius. And my dear friends, when it comes to inside, this is inside at small r. For inside point, we say small r is less than the radius capital R. KQR divided by capital R cube, where capital R is the radius. This is the electric field inside. This is the electric field inside. This is the electric field inside. Now, my dear NEET aspirants, listen to me very carefully. Listen to me very carefully. So we say, if somebody asks you plot the graph between electric field versus R, plot the graph between electric field versus R, we say electric field is directly proportional to R inside. So inside electric field is directly proportional to R. This is inside. And this is surface where capital R is equal to capital, small r is equal to capital R. And when you move outside, we say electric field is inversely proportional to R square. This is outside. This is outside. As simple as that. So electric field is inversely proportional to R square outside. Electric field is directly proportional to R. We say inside. Guys, tell me in the chats, is this clear? Tell me in the chats, is this clear? Everybody. Now, guys, one more thing I just want to show you over here. What is that? It's a small thing, small thing. See. Let's suppose if I say, guys, electric field outside, this is a hollow sphere. Electric field outside is KQ divided by small r square. See. Can I not say, guys, we say charge is present on the surface area of this. Charge is present on the surface area of this hollow sphere. Now, can I use over here sigma? Sigma is equal to charge upon area. We know that whenever charge is present on the area, we say sigma is equal to charge upon area. So can I say this charge is going to be sigma into area? Yes. So this charge is going to be sigma into area. What is the area of surface area of sphere? 4 pi r square. 4 pi r square. Okay. R is the radius. Now put it over here. Put it over here. So this electric field will be K divided by small r square, and instead of this Q, it will be sigma 4 pi capital R square. So can I not it write like this? So K divided by R square. So instead of K, we can write 4 pi epsilon naught. And then we say this R square. And in the numerator, you have sigma 4 pi capital R square. Yes. So can I say in this particular case 4 pi and 4 pi will be cancelled? So electric field will come out to be sigma into R square divided by epsilon naught into small r square. This is the electric field outside of the hollow sphere in terms of sigma. Okay, in terms of sigma. Okay. Now. What is the electric field present on the surface? Sir, KQ divided by capital R square. Now, guys, tell me, how do you write this charge? Sigma into area. Area is 4 pi R square. Yes, sir, directly put it over here. So, what is electric field on the surface? Sir, instead of K, you can write 4 pi epsilon naught. Then you have this R square. And in the numerator, instead of Q, you put sigma 4 pi capital R square. 4 pi capital R square. 4 pi capital R square 4 pi. So electric field is going to be sigma divided by epsilon naught. Absolutely clear, sir. Absolutely clear, sir. Oh, tell me, oh, is this clear? Is this clear? This is electric field in terms of sigma. Electric field in terms of sigma. Electric field in terms of sigma. Okay. 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 Let's talk about this one, guys. Let's talk about this one, guys. See, see, this is the electric field outside. This is in terms of charge. So can I write, my dear friends, rho is equal to charge per unit volume? Array, sir, yes. Because here charge is present in the volume. It's a solid sphere. Now take it over here. Charge is going to be rho into volume. Sir, charge is going to be rho. What is the volume of this sphere? That is 4 by 3 pi r cube, where r is the radius. Now put it in this equation. So electric field outside is going to be, sir, k divided by r square. Instead of q, it is a rho 4 by 3 pi, we can say r cube. Now electric field is going to be k. Instead of k, we can write 4 pi, I would say epsilon naught. Then we say this r square, and we say rho 4 divided by 3 pi r cube. Okay, now tell me, what can you cancel over here? Sir, 4 and 4, pi and pi you can cancel. So electric field will come out to be rho into r cube, divided by 3 epsilon naught r square, 3 epsilon naught r square. Array, sir, done and dusted, sir, done and dusted, sir. This is the electric field due to a solid sphere outside in terms of rho. This is in terms of charge. So basically, you can do the conversion from your end also. Just you have to convert this charge. Instead of this charge, you need to put what? Rho into 4 by 3 pi r cube. Here also you can put rho into pi r cube, then simplify, you can get the answer. Please tell me in the chats how many of you understood this. Please tell me in the chats how many of you understood this. Quick, quick, quick. Tell me, oh. Now, guys, take a look. This is the question from IIT JEE 2014. You have to tell me electric field at this point P. You have to tell me electric field at this point P. You have to tell me electric field at this point P. These are the solid spheres. Solid spheres. Oh, it is mentioned solid spheres. Now, guys, see. Electric field in this case at this point P. Now tell me, is this point outside of the solid sphere, on the surface, or inside? See. This is a solid sphere. It has charge q, radius r by 2. You have to tell me electric field at r distance. If radius is r by 2, r will be outside. And here, its radius is r. So here r will be on the surface. Here, you have to find electric field at r. In all the three cases, you have to find the electric field at r. So here r is going to be inside because its radius is 2r. So here I need to use outside formula. That is kq divided by small r square. Sir, k is q. K. Charge is q, r. Small r is the distance outside where you have to find the electric field. That is capital R over here. kq by r square. Second, you need to use the surface formula over here. On the surface, it is kq divided by capital R square. R is the radius. So that is k. What is the charge on this? That is 2q. divided by, and what is the radius? That is r square only. So this is the electric field in first case, this is the electric field in second case, and electric field inside in the third case. Because this point is inside of the solid sphere, and inside electric field is kq small r divided by capital R cube. Now k, what is the charge on this one? That is 4q. So it is 4q. And r is the distance inside where you have to find the field. That is capital R. Instead of small, I am writing capital R divided by. This r is the radius. What is the radius over here? 2r. So that is going to be 2r whole cube. So this is 4kqr divided by 2 into 2 into 2. That is 8r cube. So 4 ones are 4 twos are r and this. So that is kq divided by 2r square. So this is electric field in all the three cases, guys. Here inside formula, here surface formula, here outside formula. That's it. That's it. Just one line question. Just one line question. Okay. Just one line question. Find the electric field at point P and S. Find the electric field at P and S, point P and S. This point P and this is the point S. So here charge at the center is Q. This radius is 2r. This radius is 4r. This is point P. This is S. This radius is r. This is plus 2q. This is 3r, this radius. This is an important question. So please take a look properly over here. Please take a look properly over here. Okay. See, guys. If you have to find the electric field at point P, let's find at point S. At point S. Let's find electric field at point S. See, guys, these are the hollow spheres. These are the hollow spheres. Hollow spheres. This is plus 3q. If you have to tell me electric field at point S, take a look at this point S. This point S is outside of the bigger sphere. This point S is outside of the smaller sphere. Point S is outside of the bigger sphere. Point S is outside of the smaller sphere. And there is a center charge at the center also. Yes. So can I say electric field at point S? First, it will be due to this charge. That is kq divided by. At what distance it is? We can say 4r whole square. Absolutely, sir. First, you have to write due to this charge at 4r whole square. kq by r square. Then due to this sphere, for this sphere, this is the outside point. At what distance? All the three charges, this sphere, bigger one, smaller one, and the middle charge have got the same center. So due to this sphere, electric field is going to be k into 2q because its charge is 2q divided by, at what distance from the center? 4r whole square plus. Due to bigger sphere, the center of the bigger sphere is here only. From its center also 4r distance. So that is k. What is the charge on bigger sphere? That is 3q divided by, we can say 4r whole square. Now guys, see. K divided by 4r whole square is common. K divided by 4r whole square is common. So q plus 2q plus 3q. Q plus 2q plus 3q. That is 6q. 6kq. 6kq divided by 16 r square. This is the electric field at point S. This is the electric field at point S. Now, when we talk about the point P at at point P. At point P. Now see, at point P is inside of the bigger sphere. So due to the bigger sphere, inside electric field is zero. Why? Because in case of a hollow sphere, electric field inside is zero. So I can say electric field at point P. Due to the bigger sphere, electric field at point P is zero plus. Due to the smaller sphere, this point is outside of the smaller sphere. So K charge over here is 2Q divided by at what distance from its center, that is 2R. So it is going to be 2R whole square plus electric field due to this charge, that is KQ divided by it is at what distance, that is 2R whole square. Now K divided by 2R whole square is common. So what remains inside? That is 2Q plus Q. So 2 square is 4. So K divided by 4R square, and then we say it is 3Q. So it is 3KQ divided by 4R square. Guys, please tell me in the chats if this is clear. Please tell me in the chats if this is clear. I need to know everybody out there. Please, 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 please. Give me the signal in the chats if this is perfectly clear. Forty minutes only left. In next 40 minutes, we'll complete it. Okay. This question I'm giving you as homework. You guys will be doing it from your end. Let's move on to the electric field due to a charge sheet. Electric field due to a charge sheet. Okay. First, we'll be talking about the non-conducting sheet. First, we'll be talking about the non-conducting sheet. Okay. Yes. First, we'll be talking about the non-conducting sheet. Okay. Now, guys, electric field due to an infinitely long non-conducting sheet. Let's suppose we studied electric field due to a ring, electric field due to a rod, electric field due to infinitely long rod, electric field due to a solid sphere, hollow sphere. Now there is a sheet. We say what is the electric field due to a big sheet, non-conducting sheet at this point. So electric field due to a non-conducting sheet is simply sigma divided by 2 epsilon. That's it. You'll be directly remember. Sigma is the charge per unit area. Okay. Sigma by 2 epsilon naught. Now, my dear NEET aspirants, we say since sigma is equal to charge upon area, charge present on this is, let's suppose, Q, area is A. So can I not say this electric field will be, instead of sigma, you have Q divided by 2A and then we say epsilon naught. This is the electric field. This is the electric field due to a charge sheet. Okay, this is an electric field due to a non-conducting sheet in terms of charge. In terms of charge. This is in terms of sigma. Now, guys, and does this electric field depend upon the distance from the sheet? No, sir, it does not depend upon the distance from the sheet. So whatever is the electric field here, same will be here, same will be here, because it's an infinitely large sheet. So whatever is electric field here, here, it will be same. Now, if I say conducting sheet or conducting plate looks something like this. Conducting plate looks something like this. It looks like these are the two sheets actually. And in between the two sheets, there is a gap with no charge. And Q is the charge distributed in this case. And when I say due to a conducting sheet, electric field is sigma by epsilon. Due to a non-conducting sheet, what is electric field? Sigma by 2 epsilon naught. Due to a conducting sheet, it is sigma by epsilon naught. And guys, here, we say sigma is total charge. Total charge is Q. Total area. How much is total area? A or 2A? 2A. Area of this, that is going to be 2A. Now put it over here. Electric field will come out to be Q divided by 2A epsilon. In terms of charge, electric field due to both sheets is same. Obviously, because if Q charge is distributed on one sheet here, same Q charge is distributed on two sheets over here. That's why in terms of charge, it is same. But in terms of sigma, it is going to be different, boys and girls. It is going to be different. Okay. Now, guys, take a look. You have got a sheet over here. This is a sheet. And you have got another sheet over here. This is plus sigma. This is minus sigma. You have to tell me electric field at point A. You have to tell me electric field at point B. You have to tell me electric field at point C. Okay. Now, guys, see. When it comes to electric field at point B, due to this infinitely, and this is what? Non-conducting sheet. So due to non-conducting sheet, electric field at this point will be something like this. And that is sigma divided by 2 epsilon. Due to this, electric field will be towards sigma divided by 2 epsilon. Sir, will it be same at point A due to both? Yes, because it does not depend upon the distance. So this and this will be cancelled. Electric field at A will be 0. Sir, what about electric field at point B? Due to this positively charged sheet, it will be sigma divided by 2 epsilon naught. Due to this negatively charged sheet, it will be sigma divided by 2 epsilon. So this plus this is 2 times. So electric field at B is 2 times sigma divided by 2 epsilon naught. 2 and 2 will be cancelled. Sigma divided by epsilon. Sir, what about point C? At point C, due to this negatively charged sheet, electric field is towards sigma divided by 2 epsilon. Due to this sheet, electric field is away, sigma divided by 2 epsilon naught. This and this will be cancelled. Electric field at point C is 0. Electric field at point C is 0. Okay. So at A and C, it is 0. At B, it is non-zero. It is non-zero. Okay. So let me just give you a question homework. Find the net electric field at A, B, C, and D. this point A, this point B, this point C, this point D, and this point E. Okay, all are non-conducting sheets. This is your homework. I just want to see how many of you would be able to solve this. Okay, this is your homework. Find the value of sigma if the charge Q attached is in equilibrium. The charge Q is in equilibrium. Find the value of okay. Find the value of sigma if the charge Q is attached. The charge Q attached, if charge Q attached is in equilibrium. See, guys, this is a non-conducting sheet. Okay, so charge is present on the sheet. Obviously, it is repelling. It is repelling this charge. So this charge Q, its mass is m. It is in equilibrium. I have told you, if the charge, whenever I say charge is in equilibrium, balance the forces. So on this, guys, on this, we say force acting in the downward direction is mg. In this, it is tension T. Okay. And in this direction, it is, if this is theta, this is going to be theta. This is T cos of theta. And in this direction, it is T sine of theta. And in this direction, if it is electrostatic force. Because due to this sheet, it is pushing it with the electrostatic force. Now, can I say this will be equal to this if the charge in equilibrium? I can say T sine theta is equal to electrostatic force. T cos theta is equal to mg. Balance the two equations. T and T will be cancelled. Sine theta by cos theta is equal to tan theta. And electrostatic force in this particular case is Q times of E divided by mg. Q times of E divided by mg. Okay. Now guys, we can say we are supposed to find what? Sigma. So we can say, take it over here. So this is going to be tan theta. Then we say mg is equal to Q times of E. And instead of E, this is charge electric field due to a non-conducting sheet. You can say sigma divided by 2 epsilon naught. Yes, sir. Now take it over there. So 2 epsilon naught mg, then we say tan theta is equal to Q into sigma. So sigma is going to be 2 epsilon naught mg tan of theta divided by, we say, Q. Is this clear? Is this clear, guys? Is this clear? Now we have motion of a charged particle in a uniform electric field. Motion of a charged particle in a uniform electric field. Guys, see, one thing I just want to say over here. Whenever you place a charged particle in an external electric field, sir, this external electric field may be because of some charge. And you are placing a charged particle in this external electric field. The first thing is force acts on this charged particle, that is Q times of E. Okay. Whenever you place an external charge in an external electric field, force acting is q times of e. Now, since we say acceleration is force upon mass, acceleration is force upon mass. Whenever force acts, body accelerates. So acceleration is force by mass. So acceleration is force is q times of e, mass is m. So acceleration is qe divided by m. Acceleration is qe divided by m. Now, if I say, my dear friends, if force is acting on this particle, after some time it will reach here. So it will have some velocity. So we can say velocity is v is equal to u plus a into t. This is the velocity of this charge after time t. After time t, initial velocity is 0, initially at rest. So velocity is equal to initial velocity is 0 plus acceleration. Acceleration is qe divided by m into t. So velocity is qe divided by m into t. This is the velocity of the charge after time t. And clearly you can say velocity is proportional to time. If somebody wants you to plot the graph between velocity versus time, it is going to be directly proportional. Okay. So whenever you place an external charge in the external electric field, it experiences force q times of e. Due to force, it will have acceleration qe by m. So when it moves forward, it will have velocity qe by m into t. Now if somebody says, how much is the displacement covered? Sir, for displacement, we can use S is equal to ut plus 1 by 2 at square. Initial velocity is 0. So displacement will be 1 by 2. What is acceleration? qe divided by m into we say t square. So this displacement is going to be qet square divided by 2m. This is the displacement. And this s is proportional to t square. If somebody wants you to plot the graph between s and t, so it is going to be upward parabola. Why? Because s is proportional to t square. Oh, tell me, is this clear? Okay. Then you have momentum. Momentum. Guys. Since it has mass, it has velocity. What is momentum? Momentum after time t. Guys. We say momentum is equal to mass into velocity. So momentum is equal to mass into what is the velocity after time t? That is qet divided by we say m. This m and m will cancel. So momentum is qe into t. This is the momentum of the charge after time t. So graph is going to be straight line between momentum and time because p is directly proportional to t. If somebody asks you, sir, what is kinetic energy? Kinetic energy is going to be 1 divided by 2 mv square. So 1 divided by 2m. What is velocity? qet divided by m whole square, because this is velocity. Velocity of the charge after time t is qe divided by m into t. So this is q square, e square, t square, m square. Now this m and this will cancel. So it will be q square, e square, t square divided by 2m. This is the kinetic energy. This is the kinetic energy. And kinetic energy is proportional to time. So it is going to be like this. Kinetic energy is proportional to t square. Okay. Now velocity after displacement s. Sir, what is this? This is velocity after time t. Equation of velocity in terms of time. Now for this we can use v square minus u square is equal to 2as. So v square is final velocity. Initial velocity is 0 is equal to 2. Acceleration is qe divided by m into vcs. So V will be equals to under root of 2QES divided by M. This is also velocity of the charge, but after displacement S. After displacement S. If I say kinetic energy after displacement S, so kinetic energy is 1 by 2 mv square. Now see, here this is kinetic energy after time t. Kinetic energy after time t. So after 5 seconds, how much is the kinetic energy? Use this formula. After 5 meters, how much is the kinetic energy? Use this formula. So this kinetic energy is going to be 1 divided by 2m. Instead of v square, you can put this. That is 2QES divided by m. Now 2 and 2, m and m. So kinetic energy in this case will be QE into S. And here, graph between velocity and displacement, it will be something like this because V is proportional to root S. Is this clear? Oh? Is this clear? Okay. Just give me a second, I'll come. Just give me a second. Hey, Tamil Nadu boys and girls. It is minus 5 degrees over here. It is minus 5. Okay. Now, guys, take a look over here. Find the time of fall of electron in comparison to the time of fall of proton in a gravity-free space. See guys. Let's suppose you have got an electron. It is released in the electric field. Electric field is upwards. And there is a proton. It is also released in the upward direction. Okay. And one thing I forgot to tell you, that is, if the charge is positive, then force will be in the same direction of electric field. And it will be Q times of E. And if charge is negative, force will be in the opposite direction of electric field. Q times of E. Okay. Then my dear friends, see, if electric field is upward, electron has got negative charge, force will be downward. Due to this force, it will fall down. If electric field is downward, force on the positive charge will be also downward in the same direction. It will fall down. Now guys, listen to me very carefully. We say, we have to find how much is the time taken in falling down in this case, how much time this will take in falling down in this case. We say S is equal to ut plus 1 by 2 at square. S is equal to ut plus 1 by 2 at square. S means this height. Okay. And whatever is the height over here, same will be the height over here. Initial velocity, both are released. Initial velocity is 0. So S is equal to 1 by 2. Acceleration is QE divided by M into T square. Take it over here. 2M into S divided by Q into E. It will be equals to T square. Okay. So T is going to be under root of 2ms divided by Q into E. 2ms divided by Q into E. 2ms divided by Q into E. Okay, 2ms divided by Q into E. Now, my dear NEET aspirants, in this particular case, we say in both the cases, mass is different. Yes. We say height, they are coming down by the same height. S is same. Charge on electron and proton, magnitude wise, both is same. E is same. Electric field, both are placed in the same electric field, just the direction is opposite. It is same. So can I say these are all are constants, so time only depends upon mass. The one which has more mass will take more time in falling. We say mass of proton is greater than mass of electron. So time of fall of proton is greater than time of fall of electron. So electron will take less time in falling, proton will take more time in falling. Is this question clear? Because see, we got the value of time. Time depends upon mass, displacement, QE. We say since displacement, QE, these are constants. So take these out of the equation. So time only depends upon mass. The one which has more mass will take more time in falling. That is proton. If proton, deuteron and alpha particle are placed in the uniform electric field, find the ratio of their momentum after time t. Okay. Proton, deuteron, okay, and alpha particle. When it comes to the charge on proton, it is E. Charge on deuteron, it is 1h2. It is also E. Charge on alpha particle, it is 2E. When it comes to the mass of proton, it is M. Mass of deuteron, it is 2M. Mass of alpha particle, it is 4M. Deuteron is a particle. It has mass 2 times the mass of proton. It has charge same as the charge of proton. Alpha particle has charge 2 times the charge of proton. Mass 4 times the mass of proton. As simple as that. Now, you have placed all the 3 particles, proton, deuteron, alpha particle in the external electric field. You have to tell me the ratio of the momentum. See guys. When it comes to the momentum, that is QE into T. This is the formula of momentum. Momentum of a charged particle after time T. When I say momentum of proton is to momentum of deuteron is to momentum of alpha particle. Guys. In this particular case, charge, electric field is same, time is same. For all the three, they are placed in the same electric field and time is same. So momentum only depends upon charge. Now see, what is the charge of proton, that is E, is to? What is the charge of deuteron, that is E, is to? What is the charge of alpha particle, that is 2E? This and this. So 1 is to 1 is to 2. Even you can find the kinetic energy ratio also. We say kinetic energy of proton is to kinetic energy of deuteron is to kinetic energy of alpha particle. Now tell me guys, when it comes to the kinetic energy of a charged particle after time t, what is the kinetic energy of the charged particle after time t? Q square E square T square divided by 2m. We say Q square E square T square divided by 2m. Now see, charge is same. No, charge is different. Electric field is same. Time is same. It is same. So kinetic energy only depends upon what? Only depends upon what? That is Q square divided by m. Q square by m. Now see, we got the formula. So basically, whatever is constant in the equation, throw them out. Whatever is constant in the equation, throw them out. Okay? So we say Q square by m. Now what is the charge of proton? E divided by m. So that is E square divided by m is to. For deuteron, E square divided by 2m. E square divided by 2m is to. Alpha particle, 2E square divided by 4m. That is 4E square by 4m because it is 2E whole square. Now 4 E square by m, E square by m, E square by m. This is 1 is to 1 by 2 is to 1. So now this is 2 is to 1 is to 2. Okay. Now guys, let's understand this. Let's understand this. See guys, or let me explain this over here only. It is not that difficult. Charged particle projected perpendicular to the electric field. Now see, here charged particle is projected in an electric field which is parallel to the electric field. Whatever is the direction of this velocity, so it is projected something like this, parallel to the electric field. Now in this particular case, if this is a charge q, it is entering the electric field with velocity u. Electric field is upwards. What is the angle between velocity and this electric field? 90. That's what we say. Charge is projected perpendicular to the electric field. Charge is projected perpendicular to the electric field, boys and girls. Now, in this particular case, when the charge moves inside the electric field, we say force acts on it Q times of E. And electric field is present in the distance D. Okay. Now it goes. See. The charge wanted to basically go straight. But due to this force, electrostatic force, it is being deviated in the upward direction. It is deviated from the path. And this is the velocity v with which it comes out. At an angle of theta. At an angle theta. Now, my dear friends, if I say in this particular case, the motion is along the x-axis as well as y-axis. What does that mean? This charge is basically moving forward as well as it is going upward. It is moving upward as well as we say forward. Now, in this particular case, boys and girls, we say, is there any force acting on the charge in the x direction? No. Force in x direction is 0. Then I would have mentioned. And what is the force in y direction? What is the force in y direction? Force in y direction is q times of E. This is along y-axis. And if I say initial velocity, in x direction, that is u. This velocity is completely in x direction. Initial velocity in y direction is how much? 0. No velocity is acting along y-axis. Now, if I say if force is in x direction is 0, what is the acceleration? Acceleration is force by mass, so acceleration is also 0. Now, if I say force along y direction is q times of E, acceleration along y is force upon mass, qe by m. Now, if I say velocity v is equal to u plus a into t. Acceleration, this is along x. You are supposed to use these equations along x, along y. So acceleration in x direction is 0. Whatever is vx, that is ux. So vx is equal to ux is equal to constant. Okay. And velocity in y direction is qe by m into t. Guys, let me derive all of these because it will create confusion else. Let me derive these. See, guys, when a charge enters the electric field perpendicularly, it follows the parabolic path. It moves along x-axis also, it moves along y-axis also. Okay. Initially, it is thrown horizontally. Initial velocity is in x direction only. And y direction, initial velocity is 0. No velocity in y. If I say, sir, is there any acceleration in x direction? We say, sir, 0. Why? Because force in x direction is 0. So we say acceleration is force upon mass. If force in x direction is 0, acceleration in x is 0. If I say, what is the force along y direction? Sir, this force, q times of E is along y direction. So that is q times of E. So what is the acceleration along y? That is force upon mass. That is qe divided by m. Let's suppose after some time body reaches here. Here velocity is v. What is the velocity after time t? V is equal to u plus a into t. Guys, since we are talking about the x direction motion, so we will find this vx. So this is vx. So here we'll use ux and ax because we are using this equation in x direction. So acceleration in x direction is 0. Whatever is final velocity in x direction, same will be the initial velocity in x direction, that is u. Now use over here, v is equal to u plus a into t. So this will help us to find vy. So this is in y direction, y direction, y direction. So vy is going to be initial velocity in y direction 0. Acceleration in y direction is qe divided by m into t. Okay. Yes. 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 Okay. Now, my dear friends, listen to me very carefully. Listen to me very carefully. Two things I just want to say over here. If I say, if I say, sir, this was the original path. How much it has deviated from the original path? This is what we call y. And this is given over here. That is QE divided by 2mu square into x square. Okay. X is basically this distance. You say this x is equal to d. Okay. Sir, how much it is deviated from its original path? That is this y. And sir, what is the angle of this theta at which it is coming out? This is the angle at which it is coming out. Theta is equal to tan inverse of QED divided by mu square. This is the angle at which this particle comes out of the electric field. Theta is equal to tan inverse of QED divided by mu square. And even if you want to find this velocity, guys, this velocity is going to be under root of this square plus this square, Vx square plus Vy square. So V is going to be under root of, what is the value of Vx? That is u square plus, what is the value of Uy? That is QET divided by m, its whole square. Its whole square. Okay? Its whole square. Is that clear? Now, guys, electric dipole. We say, how do we define electric dipole? When two equal and opposite charges are placed at a very small distance, it forms dipole. When two equal and opposite charges are placed, like this is minus q and this is plus q. When two equal and opposite charges are placed at certain distance, it forms electric dipole. And we say every dipole has a dipole moment. How do we write the dipole moment? Dipole moment is magnitude of charge multiplied by separation between the charges. Okay. And the direction of dipole moment is from negative charge to positive charge. Negative to positive. Okay. Let's suppose if I say, sir, this is minus 2q and this is plus 2q. Is this a dipole? Yes, this is also a dipole. Because two equal and opposite charges placed at certain distance. Okay. Yes. And sir, could you please tell me the dipole moment over here? Dipole moment will be magnitude of charge, that is 2q, distance is d, 2q into d. Let's suppose the question is something like this. Take a look, guys. Find net electric dipole moment. See, in this particular case, sir, you can resolve this in two dipoles. See, I will show you. Can I write this minus 2q as minus q and minus q? Find net electric dipole moment. And this is over here plus q and this is over here plus q. Guys, always remember, I have told you, Electric dipole moment is from negative charge to positive charge. Electric dipole moment is from negative charge to positive charge. So this is P. This is also P. Okay. This angle over here is at 120 degrees. Okay. Now, guys, if you have P and P, what is going to be the resultant dipole moment? Net dipole moment is also going to be P. Because when you have two dipoles at an angle of 120, resultant is P. And this P will be, that is Q, and distance is L, that is Q into L. Q into L. Sir, I have this question. Take a look, guys. You have to find net electric dipole moment. In this particular case, first you need to basically resolve this in the dipoles. Now, guys, see, this is minus Q. Keep this minus Q as it is. This is 3Q. I want you to break this in plus Q and plus 2Q. Now, this 4Q, this is minus 2Q. This is minus 2Q. This is 2Q over here, plus 2Q. And this distance is L. Now, my dear NEET aspirants, if I say, how many dipoles are over here? We say first dipole is this, from negative to positive, it is P. Second dipole is this, from negative to positive, it is 2P. Why 2P? Because here it is 2Q, 2Q. Dipole moment is double. And from here, it is, we say, 2P. Now, can you make these once again? Sir, in the upward direction, it is going to be P. In the backward direction, this one, it is going to be 2P. In the downward direction, it is going to be 2P. Now, guys, tell me, what is the resultant of this and this? 2P minus P. It is going to be P. And this is over here, 2P. Now, don't you think resultant of this one and this one will be this, P net? And P net in this particular case will be under root of this square plus this square. That is 2P whole square plus P square. 2P whole square means 4P square plus P square. That is 5P square. So that is going to be root 5 of P. This is the net dipole moment. Is it clear? Oh? Is it clear? I'll explain once again. Draw these dipoles once again. See, in the upward direction, it is P. In the backward direction, it is 2P. In the downward direction, it is 2P. What is the resultant of this one and this one? They are opposite. So 2P minus P, that is P, but in the downward direction. Direction of net is always along the direction of bigger one. So this is 2P and this is P. Now, what is the resultant of this one and this one? If you have two vectors at an angle of 90, so net in that particular case is under root of this square plus this square. That is 2P whole square plus P square. So 2P whole square is 4P square plus P square. So that is 5P square. Square and root will cancel, but a root 5 will remain and root 5P. Electric field due to an electric dipole. Now, guys, see, since dipole has got charge in it, so it creates electric field, because whenever there is charge, it creates electric field. Now, you have to tell me electric field due to this dipole at this point P, at this point P, at an angle of theta, which is at x distance. So, electric field due to this dipole at point P, E is equal to Kp divided by x cube. Then we say under root of 3 cos square theta plus 1. This is the value of electric field due to a dipole at arbitrary point. At arbitrary point. Now, guys, if you move on to this point, this is the actual point. Now, if you move on to the actual point, so means you have to lower this angle. At actual point, don't you think the value of theta must be equal to 0? Yes. So electric field will come out to be Kp divided by x cube. Then we say under root of 3 cos square of 0. Cos 0 is 1. Okay. So that will be 3 plus 1. That is 4. Root 4 is 2. So it will be 2 Kp divided by x cube. So electric field at this point will come out to be 2 Kp by x cube. Let's suppose if we find the electric field at this point, okay, it is perpendicular bisector, or we say equatorial point, and value of theta over here is 90 degrees. You have to increase this. So electric field will come out to be Kp divided by x cube. Then we say under root of 3 cos square of 90, cos square of 90 plus we say 1. Cos 90 is 0, this term is 0, so root 1 is 1. So electric field will come out to be Kp divided by x cube. So in nutshell, you will be remembering electric field due to a dipole at arbitrary point is Kp by x cube under root of 3 cos square theta plus 1. And at actual point is 2 Kp by x cube. And at equatorial point is Kp by x cube. Okay. At equatorial point is Kp by x cube. Okay. Is this clear? Is this clear? And one more important thing, guys. Electric field due to this at this point will be something else. Something like this. This is the electric field. Okay. Okay. And this angle, we say this angle is alpha. Angle between electric field and this x is alpha. If somebody says what is the value of this alpha, you say tan alpha is equal to tan of theta divided by 2. Remember this directly. See, electric field due to a dipole at arbitrary point is this, and direction is something like this at an angle of alpha with x. Now, if somebody says what is the value of tan alpha, it is tan of theta by 2. And electric field at actual point, its direction is this. Okay? Towards right. Electric field at arbitrary point, its direction is opposite. As simple as that. Guys, if the dipole moment is in this direction, this is very important. The direction of electric field at actual point will be same as dipole moment. And at equatorial point, electric field is opposite. That's it. So, let's take a look at certain questions. So, if I say, let's suppose this is minus q and this is plus q. Okay. This is the direction of dipole moment. This is the equatorial point, let's suppose. The direction of electric field at equatorial point will be something like this, opposite to this one. And at actual point, it will be along. Keep this thing in your mind. Keep this thing in your mind. Okay. Find the electric field at x distance. Find the electric field at x distance. You have two dipoles. Guys, see, this point with respect to the first dipole, it is the actual point. For first dipole, this point is actual point. So can I not say, my dear NEET aspirants, in this particular case, due to this dipole, electric field at axial point is always away. That is Kp divided 2 Kp by x cube. Yes. And for this dipole, this is the equatorial point. So at equatorial point, electric field is opposite to the direction of dipole moment. So it is going to be Kp divided by x cube, because this is also x. Either you measure this x from this point. So for this dipole, this point is axial point. So for axial point, it is in the same direction, electric field. For this dipole, this is the equatorial point. So electric field is in the opposite direction. Okay. Now, my dear NEET aspirants, this factor and this factor, this is going to be net electric field, E net. That will be under root of this square plus this square, 2 Kp divided by x cube whole square plus Kp divided by x cube whole square. Now 2 square is 4. So 4 plus 1 is 5. It is going to be 5 Kp divided by x cube whole square. Square and root will cancel, so it will be root 5 Kp divided by x cube. Something like this. This is the answer to the question. Is this clear? Tell me the answer of this question. Now, guys, take a look. There is a dipole placed over here. Okay, this is P. This is a square over here. You have to tell me the electric field at point A and point B. Okay. You have to tell me the electric field at point A and point B. When it comes to the point A is arbitrary point. A is arbitrary point. Okay. And if you want to find the electric field at arbitrary point, electric field at arbitrary point is simply going to be Kp divided by x cube under root of 3 cos square of 45 plus 1. Because this angle is 45. And x is this distance, and x we can say over here is root 2l. Because this, if this is L, diagonal is going to be root 2l. So electric field at point A will be, that is Kp divided by, instead of x, I can say a root 2l whole cube. Then we say under root of 3 cos square of 45, 1 divided by root 2. Plus we say 1. 1 divided by root 2 plus we say 1. Okay. Then we say electric field at point A, it is going to be Kp and it is whole square divided by root 2l whole cube. Now this will be 3 by 2 plus 1, 5 by 2. 5 by 2. Now guys, this is root 2 3 times and this is root 2. total of 4 times root 2. So that means root 2 into root 2 into root 2 into root 2. Root 2 into root 2 is 2. Root 2 into root 2 is 2. 2 into 2 is 4. So electric field at point A is Kp into root 5 divided by, instead of root 2 whole cube into root 2, it is 4, and then we say L cube. It is electric field at point A. And when I say electric field at point B, you will be applying. B point is the actual point for this dipole. It is going to be 2 Kp divided by x cube. X is L cube. X is L cube. Okay. And this question I'm keeping you as homework, guys. Okay. Yes. This question I'm keeping you as homework. Okay. Now, guys, one topic is there, that is electric dipole placed in the uniform external electric field. Electric dipole placed in the uniform external electric field. Listen to me very carefully. Listen to me very carefully. My dear NEET aspirants, let's suppose this is the external electric field, and in this external electric field, you are keeping this dipole, minus Q and plus Q. Now see, on this plus Q, force will act in the forward direction Q times of E. On this minus Q, force will act in the backward direction Q times of E. Plus Q times of E, minus Q times of E. Now, don't you think these two forces will try to rotate the dipole? Okay. These two forces will try to rotate the dipole. Yes, sir. These two forces will try to rotate the dipole. Yes. So, my dear NEET aspirants, if these two forces will try to rotate the dipole, we say torque is created. Torque is created. Sir, what is this torque? See guys. If I say this is a body, this body is at rest. Sir, what is that one thing which will make the body in motion? Sir, that is force. Apply the force on a body. So force is something due to which a body moves. Now, if there is a rod over here, if you want to rotate this rod, sir, what will you apply? Torque. So whenever there is linear motion, there is force. Whenever there is rotational motion, there is torque. If I say this is rotating, means torque is acting on this. If I say this dipole is rotating, means torque is acting on this. Simply remember, rotation is because of torque. Rotation is because of torque. So we say torque is created whenever the dipole rotates. Due to these two forces, equal and opposite, it will rotate the dipole, torque is created. And that torque will be equals to, we say P E sine of theta. P is the dipole moment. Okay, this is the dipole moment from negative to positive. And electric field is forward. So angle between P and E is theta. So this is what we call torque, P E sine theta. Or you can write it like this also. Torque is equal to P vector cross E vector. Because AB sine theta is A cross B. A cross B. Okay. Now guys, see. Let's suppose if theta is 0, means you have placed a dipole something like this. This is the dipole moment P and electric field is forward E. What is the angle between P and E? 0. In this particular case, what will be the torque? Torque is going to be PE sine theta, sine of 0. Sine 0 is 0. In this case, torque is 0. Okay. In this case, torque is 0. Now guys, here, if this is minus Q and this is plus Q, dipole moment is opposite. Now here, angle between electric field and dipole moment is opposite, 180. So torque in this case is PE sine of 180. Sine 180 is also 0. So torque in this case is also 0. Okay. If theta is equal to 90 degrees, PE sine 90, torque in that case will be 90. Like this is negative charge, this is positive charge. So dipole moment is from negative to positive. Electric field is forward. Angle is 90. Maximum torque. And if theta is equal to 270, in that case, torque will be minus P. So basically, theta is 0, torque is 0. Theta is 180, torque is 0. Okay. And theta is 90 and 270, torque is maximum. Okay. So with this, we have finished the portion of done with electric charges and fields. Okay, done. Okay, now guys, the next chapter is going to be potential and capacitance. Potential and capacitance. Potential and capacitance. Okay, next chapter. Next chapter is potential and capacitance. Okay. So that's all for today. Okay. So take care, guys. See you. Thank you so much. And do let me know in the comments how was the session.